emerging trends of technology in current era. In collaboration with Director Higher Education, Haryana, and being organized by Computer and Electronics Department of SD College, Ambala, Kent. Institution of higher learning play a vital role in shaping the ethos of a society. They also serve as a most appropriate platform where the youth is prepared for the unique challenges of life. Sanatan Dharm College, Ambala, Kent, has been serving the cause of education by imparting value-based modern education for more than a century now and creating the benchmark for other institutions. Sanatan Dharm College, established at Lahore in 1916, under the dynamic influence of Bharat Ratna, Mahamana Madan Mohan Malviya ji, the backbone of Sanatan Dharma. After the partition of the country, the college was re-established in Ambala, and the foundation stone of this college was led by none other than the first president of independent India, Dr. Rajendra Prasad ji, on 3rd October 1951. The college has since then scaled new heights of excellence in the field of higher education. With over 3,000 students on its roll today, the college offers education in the stream of arts, science, and commerce. Beside the traditional education, the college offers vocational and self-finance programs which cater to the diverse needs of the students of this region and definitely enhances their employability skills. Over the years, it has evolved dynamically in accordance with the radical changes that has taken place in the pedagogy, policies, and information technology. Once again, I, on behalf of Sanatan Dharm College, Ambala, Kent, would like to extend my deep sense of gratitude to chief guest of this seminar, Professor Anil Vora ji, and all the resource persons of various technical sessions and the participant of this one-day seminar. Jai Hind. Over to you, Amandeep.
Thank you, sir. As we are gathered today here to have deliberations on emerging trends of technologies in current era, now I invite Head of Computer Science Department, Dr. Girdhar Gopal, to throw some light on the theme of the seminar. Over to you, sir.
Thank you, ma'am. A very good morning to all of you. So today, first of all, that is World Happiness Day, and on this, the morning of World Happiness Day, I propose on the behalf of Sanatan Dharm College that all of you who have joined directly or indirectly in this event always throw the happiness in the life. One of the stories of the happiness, which is you can directly link it with this huge innovation, technology, how the life of each and everybody has changed since past a couple of years and back also. A lot of stories behind those. One of them, the famous one by Lord Buddha, once a thief who had hid one diamond under the rug of a beggar in the night, with the purpose that in the morning he will come back and catch that diamond back again. But who knows what happened in the future? So the thief was caught and he never returned to get the diamond back. So now the ball is on the other side. The beggar was unaware of the diamond and he spent his whole life because he never take care of where he is living. He never picked the rug and cleaned the place. So he lived all the life in the same begging. when he was died and his body was cremated, what happened is people picked up the rug and then they see that, oh my God, there is the diamond under that rug. Maybe if that beggar had much space, he think upon this thing that I should change the things. At least I should clean the space where I am living. He has got that diamond way back and his life might change. The story is this pandemic, since last couple of years, it gives us the point where we must be aware of where we are and where we can. The problem is we are not ready to change, adaptable to change. Human being is very adaptable as per the Darwin's theory also. We all know about this, that we are very adaptable to the changes, but some rigidness is there. Now, technology is one thing which make this thing very beautiful in our front, so that we can change the little things like see, work from home. I don't think somebody has heard about this in the pre-pandemic era. Work from home, homeschooling. Even I'm very glad that even the nursery class students' classes will go online. What makes that possible? The technology. I know that when the technology come into mind in the last couple of years, computer science, IT, electronics, these are the three key fields which you can evolve with. That's why we have this seminar with the idea that computer science and IT is no doubt one of the fastest growing career fields in the modern era. And we have a lot of options which might be there, which might exist also, but very few of us are aware with them. Or if we are aware also, very few of us are using them. So developing the technological architecture of electrical engineering, computer engineering, computational language of mathematics also, how to solve the problems, how to design the solutions of the problems. These all are related to the technological advancements. Like the mobile phones. We all know that those keypad mobile phones, if we are there from early 2000s, those are very popular, and soon how they got a change due to the technological advancements. That change is very drastic, and it changed a lot in each and everybody's life. And it doesn't matter where you live in the world. It had an impact, a greater impact on the life. Today, the technology has been growing so exponentially over the recent years. Like there is a steadily increasing demand for bright graduates also, postgraduates, researchers, data scientists, many buzzwords who are there in this field to transform our lives into much better lives. The objective of this seminar is to make the participants up to date with the emerging trends of technologies in the current era. We have our chief guest, Professor Anil Vora sir, with us. I got to remember like in 2010, 2011, when I was in Kurukshetra University seeking my admission to the doctorate. At that time, many of us are struggling with Windows and virus, etc. in our daily lives. And then we heard a name that somebody is there who is using Ubuntu, Linux, and since past 5 to 6 years. So it might be possible that there exist the technologies, but I don't know who are using. So we go to Vora sir, and he just beautifully explained the things that this is, why don't you use it? Why are you just behind the Windows and again and again you are formatting those systems again, and once you एक बार तो पेन ड्राइव लगाते हुए भी सोचना पड़ता था कि कहीं वायरस आ गया तो मेरा तो सारा सिस्टम ही फॉर्मेट करना पड़ जाएगा. But still there exist some other parts also. So that's why we have this glimpse that we must organize such kind of event which show that how the technology is getting brighter and brighter, and it is there to make our lives better. So we are highly thankful to sir that he accepted our invitation to be the chief guest of today. Once again, I welcome you all for this seminar on emerging trends of technologies in current era. Welcome you all. Thank you. Over to you.
Thank you, sir, for so elaboratively introducing us to the theme of today's seminar. Our illustrious and eminent chief guest, Professor Anil Vora, doesn't require an introduction as he's a well-recognized figure in Haryana. He is known for his wonderful administration and high achievements of the university under his academic leadership. But to follow the protocol, now I invite young leader of Department of Electronics, Dr. Aarti Arora, to formally introduce our worthy chief guest to the audience. Over to you, Aarti ma'am.
Thank you so much, Aman ma'am. Am I audible?
Yes, ma'am, you are audible.
Thank you, ma'am, for providing me this opportunity. I'm really overjoyed to introduce our worthy chief guest, as I'm very pleased to inform that I am student of Sir. So, really, I'm very happy that I got a chance to introduce you with our lovely audience and all participants. So, it's my proud privilege to introduce our worthy chief guest, Dr. Anil Vora, who is Dean of Colleges, Kurukshetra University, Kurukshetra. He is working towards the growth of the colleges affiliated to Kurukshetra University. Currently, he is holding position of Dean of Colleges. He has been the Dean Academic Affairs, Dean Research and Development, Dean Faculty of Sciences, Dean Faculty of Engineering and Technology at Kurukshetra University, Kurukshetra. He has been the chairman of Department of Electronic Science 3 times. He is also the member of several academic bodies and administrative committees. He also visited Cambridge University, UK for development of new technology for the solar cell applications. There are more than 125 research papers in national and international referee journals in his credit. List of his achievement is very long. So we are very much honored to have you here today. We are really feeling very happy to listen you. So I will invite you, Dr. Anil Vora, to please share your words of wisdom with us on this platform. Over to you, sir. You please unmute yourself, sir. You are muted. Aman ma'am, am I audible?
Yes, Aarti ma'am, you are audible.
Okay.
Am I audible now, please?
Yes, sir. Yes, sir.
Yes, sir.
Just a second. Still audible now?
Yes, sir, you are audible.
Dr. Rajinder Rana, Principal of SD College. Dr. Girdhar Gopal, HOD Computer Science. Dr. Aarti Arora, Dr. Raman, all members of the organizing team, dear participants of the webinar, all other who are listening to me. Very good morning to all. So first of all, thank you for inviting me to interact with you during this webinar, using trends, recent technologies. So as you are already aware that we have been going through a large changes in technology over past many years. So technology in general, it is a greatest method to change our world of the way we work, we live, and so in general, what we have innovative solutions that are required to the problems which are posing the global challenges, and always this has been true since beginning, since maybe 16th century, even when the wheel was invented, there was a challenge always how to do this. So technology, since human being they came maybe in the way of life, they have been inventing some or other technologies, and over years now you observe that are having large surge in. Okay. So when we say technology, then what we want to, let us talk about only science. And so we have very large changes, very large developments, many new developments in these two areas. We have, first of all, the main area which is coming up, that is electronics in general. Since I am from electronics, so I will talk in general about electronics, but we will be applying that to also. So let us say we take the case of a fast computer. Then what we want to do, we require a fast computing. Basically, for that we need to have faster processors, we need to have faster memories, we need faster motherboards, even we need to have faster hard disks. Okay, so all these, I've talked about 3 or 4 of them. So all these areas, they require specific technology to match the performance. Okay, if it is robotics, or it is, let us say, the latest is, say, whatever latest robot is there, then that will be using that particular computer. So when we talk about, say, let us say motherboard, then there are many ICs on that. Okay, so people earlier, there used to be large computers, so maybe a full room was made for one computer. Then they shifted to desktop types and find that as desktop still there are a large number of ICs. Okay. Then these ICs, they were merged together, and today you will find in good motherboards, you find there are only 1 or 2 ICs. Okay. So what have happened to others? What have happened to others? That has happened due to the technology developments in electronics side. Okay. And what they have done, they have then merged the functionality of many ICs into a single IC. And you will find that when you reduce the size of motherboard in a computer, in general, there is a trend to the speed. The delays, they are reduced. Delays in the communication of signal from one place to other place, one IC to other IC, or one, let's say, gate to other gate, that gets reduced. And in general, there is increase in speed. So these delays, they have to be removed. Zero delay means best possible speed, but that is ideal case. In general, there will never be zero delays. There will be some delays also. Okay, but they can be reduced. They can be made smaller. So people then have, first of all, reduced the number of ICs, and their way they have reduced the number of interconnects between ICs and the gate, thereby reducing the distance over which the signal travels from one place to another. Okay, so this way what happens, we have reduced the delays. Similarly, when you want to increase the functionality in a particular IC, then what we do? To do something that the functionality on IC increases. How that increases? That increases by putting on number of transistors on, more number of gates, or number of transistors on that particular IC. Only then you can increase the functionality. Now, let us say we have an IC, typical IC. Let us say we have it there and it is already in use. It has been optimized already. So you need to increase the functionality. How do you do that? We pack in more number of transistors, but general area of transistor is always fixed. Okay. This area is somewhere around probably today it is around 5 by 5 mm. So that is the maximum area they tend to use. Okay. So before that, what happened? There was a trend to increase the number of ICs. And you'll find that big workstations, for example, Sun workstations, they were very popular at one stage. So they had large motherboards. Not a picture now, but you find that they are large inside. The motherboards, they are large inside. So they were faster. Why? They were still they were working very fast. Why? Because they used to have smaller interconnects in those cases. They were optimal. But when the functionality is increased on IC, what we do, we tend to pack in more number of transistors, and then we need to reduce the number of we need to reduce the area a transistor will. That we need to. Only then we can increase the number of transistors on chip. Why? Because its area is fixed, 5 by 5 mm. Okay. So in general, what we are reducing the device size or the transistor size on the IC. That way, when we do that, what happens, we are increasing its speed. Okay, so that is inherent property of that. We increase its speed. When we increase its speed, you know that your IC will be working at a higher speed. Delays are lesser, speeds are higher, and that you are getting now better performance from same let's say IC or something. Okay, so over years this has happened. This has happened in a way that we have been noticing it. So when we were kids, there were no computers, and 1974 the first IC was made, and then people we never knew in India there was no news of that, but people world over they knew that something is going to happen. But that particular IC that was made, that was 4004 IC by Intel, that was made for a Japanese company. That was made for a Japanese company who was making calculators. They wanted a calculator which can be programmed. Okay. So Intel designed the first microprocessor for them, and that chip, that IC, was used for programmable calculators. Okay. So starting from that, then they came out with 8088. Then you know that the list is very long. So today you find that we are at core-based technology, and we have a number of cores in that. So of course they can go up to 16 cores, 24 cores, etc. There. In general, when we say our desktop is having i5 IC, that there are 4 cores. Okay. So you can increase the number of processors the computer, or you can also increase the number of cores. They are similar, but when you increase the number of processors in the computer, you will find that you have to then the number of cores. So the number of cores, they are more as compared to the number of processors. They are more. Find that when you have number of cores more, you will get a better always, because number of cores will be the same IC. Okay, so but even you will find now that we are having mobile phones which are faster. Some of them, they may be faster than a simple desktop. They may be faster than a simple desktop. So technologies, they have grown in such a manner that even small sized devices, they can be much faster than the desktop. Okay, so as you know, maybe knowing already that your mobile phones, they are based on RISC type of processors, and they are inherently faster as compared to the processors which are of CISC type and are being used in the desktops. So those are basically the technological advantages for the RISC type of processors. In future, you will find that more of the desktops will be coming to this type of processors, and they will be used. So when we say fast, then we have seen how this is to be made. We need to reduce the size of device, size of transistor, larger functionality in the same chip. You will find that your performance will be better over time. Performance of the IC will be better. Time. Desktops, they will be performing. Why we require that? As we are seeing today that many new areas, they are coming. One of that area is robotics. That is one of the fastest growing area today. Find that new ideas and new technologies, they are coming day by day. Robots, they are being made in various shapes and sizes. The main you can say the main area where they are being manufacturing side. Okay. The particular side of industry where manufacturing is done, so that is particularly prone to accidents. People, they have devised various type of robots that accidents they can, that work can be done more smoothly, so that it can be repeatedly giving you the same output without any those things they are there. Another particular area is autonomous type of aircrafts. They are also a kind of robots, or they are called simple drone. They are being in large manner these days. So the areas which were not possible to be reached by humans, they are being surveyed by of robots. many other applications are there. For example, you can survey the buildings, you can pathway surveys, particularly in Europe, where number of persons they are less than drones are being used for pathway surveillance. Maybe the missing persons, they can be located, anti-terrorist warfare, etc. Many things they are there. So other areas in robotics, they can be there. For example, exoskeleton is one of the major area where technology is being used. So it is normally called a power armor, and this can be worn by a person, and wears it, then you will find that its working power, it increases. Endurance also increases very. So it has typical application for in heavy industry, where heavy loads are to be lifted or moved, or a long stretch of work is to be done. In those cases, okay, construction industry is very large demand. So these areas, they are typically very recent, and they are coming up in a large manner. You find in coming few years that robots, they are taking a big lead. You find that robots, they can infiltrate you home also, and already people, they are demonstrating the use of robots in several other ways also. One company, Boston, they have made a artificial dog. That dog can behave just like a normal dog, but it doesn't require any particular caring, food, etc. It doesn't require still a good pet. They have demonstrated that. Cost is high, no doubt, $75,000, but many people, they have bought it. They have good feedback on it. Okay, so when we are discussing all this, then the certain areas of, not particularly computer science, but certain areas of you can say technology. So AI, for example, or machine learning, artificial intelligence and machine learning, they are particularly important. We talk about robots, and we talk about the computer vision, etc. All of them, they are there. So AI, it has been there since long, but it was not being used in large manner. Why? Because computer, they were not having that much power those days. Because they were slow, they could not match the requirements of the artificial intelligence algorithms. But today you find that fast computers are there. Most of the AI and ML type of algorithms, they have been optimized for various type of processors, particularly GPUs, graphic processing type. They have been optimized for them, and we will find that if you have a good computer, number of GPUs, your work on artificial intelligence or AI or ML, both can be very much fast. So as the machines, they take over, then we will require AI in general, and robots typically they will be requiring that. And already people, they have demonstrated, medical field, they have demonstrated remote control based surgeon, etc. Those things. Similarly, AI based car, or let us say AI and ML based car, is being developed. It is not car, it is a software. Basically, it will not be software, but it will be an IC basically. So why I'm telling you that there is no clear thing what is going to happen in future in the areas which are involving in. Okay, simple software cannot work. You need to then have a full IC. How do you do that? Normally, you form out the algorithms. Those algorithms, they are then converted into hardware form, the IC itself. Then ICs, they are dedicated for the particular. So robots, they normally use such type of ICs. Otherwise, when you do software programming, the real time of OS, real time type of the, say, computing. So those things, they require large in powers. Those powers are still not there. Okay, so when AI based cars, they are there, you will find that they can enhance certain things, but they can use certain things also. Enhancement means they can enhance the work capability of humans, but at the same time, it will also reduce the job openings or also reduce many other jobs. Okay, so Google is one of the companies working, but most of the automobile companies, they are then already armies world over, they are testing certain systems which can then use parachute type of say arrangement to deliver supplies, and it uses AI-based image recognition of the. So it has large use, typically in case of disaster, this has use. So all technologies, they have both sides. First of all, it can be used in military also, it can be used in civilian also. So when you find that military technologies, they have been fully developed, they are then shifted to the civilian use. So most of the technologies we see today, even in internet also, they started as a military type of network, but it was later shifted to the. When it comes to civilian use, then the industry has a large possibility, it has a large, say, openings, it has, so then they start. So similarly, biomedicals, they are particularly getting affected by this technology advancement. So why I'm connecting biotechnology now? Because biotechnology in future, you find that bio and electronics, they are going to be joint field soon. Devices in electronics, they are going to be so small in size that they will be matching the biomolecules in general. We are talking about very small devices, nano sizes. We are working upon. Well, they have already Intel, for example, it is producing ICs. Similarly, AMD, it is producing ICs, memory ICs, which are having feature sizes of the order of 7 nanometers. 7 is nanometers 10 to the power minus 9. People, they are looking below that, although going below 7 nanometers is very typical, very built, but people, they are still typically aimed at achieving. Okay. Recently in our lab, not in our lab, we have done something analysis that side, found that workable devices could be formed below 7 nanometers, around 5. But those were theoretical studies. People, they are practical devices can also be working. Okay, but there will be certain limit, no doubt there will be certain limit, go beyond certain device, minimum device size, those limits they are given. Okay, so biomedicals, they have also taken a large stride. Technology is coming in that. Sensors, they have been formed, and this type of sensors, they have been formed up, is working. So those sensors, they have been formed, which can be used to monitor transplants for their success or failure. Sensors, they can travel inside the body, send radio signals to instruments outside. So this is all. Then artificial type of neural implants, they can be done. So similarly, brain implants can be done. So these are typical type of things. They can be sensors, they can be MEMS. MEMS, they are micro electromechanical systems. They very useful in. Okay. So typically, they can be used to monitor heartbeat, blood pressure, etc. They can be variable sensors. They can swallowed inside the body. They can be injected inside the body. So those things is of biomedical. So small portable labs, they can be used field. So for example, viruses which are coming up, Zika virus was sequenced in field itself. So portable labs, they were formed, and in field itself was then genome sequenced. People, they have used their labs in field, then they have used backend high speed. So all these things, they require computers, and that mean you require speeds, you require higher speeds, you require higher speeds. You require higher speeds. always we look at the electronics people to better and okay, each and every system requires technology advances. For example, let us say take a simple case of robots. Robot is that it is a system which depends on many things. There can be mechanical parts, they can be there, arms are there, limbs are there, they have electrical motors, we have instrumentation is there, software is there, electronics is there. So if we talk about say mechanical parts, then arms and limbs, they can be made, let us say out of simple iron, they can be made of steel also. But what if you use a large number of elements? Say you want to make a human like robot. Find if let us say average human weight is around say 70 kg, find it will be weighing around 700. Why? Because its mechanical parts they will be so heavy that you need to then take care of those their weight also. So that is one way the robots are still being not used in large way because of their large weight. Okay, so if you can advance the mechanical parts, say arms and limbs, you need to have materials in such a manner that the arms can be made out of lightweight material. The other parts they can be lightweight materials. Then those will be technology. Those will be the technology. Electrical motors are there, so typically electric motors they are near perfection, but still there can be more advancements. But find that motors they are very small today, they can be very powerful. So those motors they are the normal motors which are used in our fans, etc. They are not used. So special motors are made for. Okay. Similarly, when you talk about the controls, then control systems they are important. Instrumentation comes into picture in that case. You have control systems which are no doubt based on sensors, then we have actuators, then we have the control lines, etc. All those things are there, but they need centrally that again you require microprocessor, you require a micro. Okay, so those things then. Okay, so advancements in those areas they so similarly when we talk about software, so software in general in robots they are to be programmed. They can be reprogrammed, they can be again reprogrammed depending on going to be used. So real-time applications they are normal software they do not work in that case. So normal OS, for example, Windows, etc., they do not work in cases. You require systems which are called real-time systems. Software again you need to then have design such a manner that it can update the things in. There is a particular area for this software. That is the software people they can work in that area. So very interesting real-time operating systems and real-time software. Okay, all these things will not work unless you have the electronics in place. Okay, fine. So above all, it is to be placed somewhere. So if you don't have electronics, nothing will be working. So you require the say latest sensors. You require the latest say actuators. Actuators, for example, motors. They are say part of it. And you require the control on that. You require for that. You require processors. Maybe single microprocessor or single code cannot make it work. So you require many of them. So all of them they need to be compatible with the time applications. So high speed. Okay, so we have discussed mechanical, electrical, let us say, instrumentation, let us say, then software and electronics. Each of them will be further dependent upon others. So it means if you want to work on a single area, say robots, then you need to be conversant with at least not one, but at least one, but not one, but many of them, so that they can be interrelated, they can be okay. So say recently we had the pandemic of COVID. It's still not over, but it is calmed down for time being. So it has changed the lives in a large manner. So we are working from home. We assist from home. Here, as Dr. Gopal said, that we didn't knew that this can be done from home, or this can be so much, say, involving for us that we think about it day and night also. Okay, so it has now put us in a more, you can say, in an area which is more dependent upon the online or more dependent on. Okay. So it was possible to have high-speed internet. It was possible to have high-speed putting devices also, and whatever we had today was sufficient, and tomorrow it will be sufficient. Okay, so if you see before this pandemic, your, let's say, internet speed, it was say 1 Mbps or 2 Mbps, it was sufficient. But when you started the online teaching, when you started the online learning classes of our children also, they are going on, you find that this speed is not require higher speed. So higher speed means require higher connection. Okay. So if you are a man of communication, you will find that how difficult it is to create one channel over a wireless say connection, say mobile connection is wireless. So over that you take one channel and you are able to send, say, data of around 2 Mbps or 3 Mbps or 4 Mbps on that. It's very difficult. It requires what? It requires a large bandwidth. Okay. So large number of users are there, so large bandwidth. So again, technological advancements are, your mobiles should be working at higher frequency, gigahertz. Here you used to have the mobiles which are working gigahertz range. The frequencies, there are 4G frequencies, they are in gigahertz range. Okay. So those technological advancements are again possible if the electronics people worked over here. If it was possible only because of the high-speed devices, only because of the small size of it. So I will be stopping here. So now what we find, we have an era which is going to show us the future. This webinar, it has taken a lead in a way. It is to talk about the recent trends, emerging technology. So my best wishes to the organizers, best wishes for the webinar, best wishes for the
Thank you so much, sir, for your beautiful words. You have took all of us from older days to the latest technology era. You told us about, you started with the old largest processors and you move ahead to the minimized processors as we are using in the current era. And you also told us about the latest technological fields like robotics, AI, machine learning, and many more. Bioelectronics is no doubt is the very much emerging technology nowadays on which the researchers are working with full energy. You highlighted all the technological advancements, and we are really benefited out of your words, sir. Moving ahead, I would like to say good morning to Himanshu, sir, who is our next resource person. And I would like to invite Aman ma'am to pay the vote of thanks to our worthy chief guest. Over to you, Aman ma'am.
Thank you, Aarti ma'am. On behalf of Sanatana Dharma College, I propose a really heartfelt vote of thanks to our chief guest, Professor Anil Voraji, who spent his busiest time gracing this occasion. Today, we had the opportunity to hear your thoughts, and this is definitely encouraging us in our future events. Your thoughts have enlightened our minds and shown us our new path. So very beautifully and in easy language, you explained how technology is advancing, shrinking the sizes of devices and increasing the speed. It was indeed a stimulating experience. If the heavens were all parchment and trees of forest all pens and every human being were a scribe, it would be impossible to record all we learned from your sharing. From the depth of our hearts, we thank you, sir, for all words of wisdom that radiated a source of energy within us. Thank you, sir.
Thank you, please. Thank you very much.
Thank you, sir. So with this, the inaugural session comes to an end and we declare it closed. Now we are proceeding to technical session 1. Respected resource person of technical session 1, Dr. Himanshu Monga, and all the dignitaries and delegates present here, on behalf of Sanatana Dharma College, I extend a very warm welcome to one and all present here. To begin with the technical session, I am profusely elated to take an opportunity to introduce our resource person, Dr. Himanshu Monga, who has distinguished career in academics and research. He is seasoned academician with 20 plus years of experience of teaching, research, industrial and academic administration at undergraduate and postgraduate courses in engineering colleges and institutions. Dr. Himanshu Monga, PhD from Thapar Institute of Engineering and Technology, Department of ECE, Patiala, Punjab, in the field of optical networks, coding and wireless network, is presently working as professor and head at Jawaharlal Nehru Government Engineering College, Sundarnagar, Mandi. He is also in charge of Dean Academics at JNGEC and OIC Computer Center. He has also worked as Director Principal of Jan Nayak Chaudhary Devilal Vidyapeeth, Sirsa. He has also served as Professor and Dean Research in Lovely Professional University, Fagwara, India. He has authored more than 140 research papers in international and national conferences and has more than 35 Thomson Reuters SCI publications to his credit. He is a life member of IEEE, ISTE, and reviewer of many renowned journals. And he has authored 8 books, chapters in renowned books. And he has successfully completed 6 projects worth 70 lakhs and successfully completed many consultancy projects. He has also published 5 patents recently and he has got long list of accomplishments on his credits. And we are really in a treat that he's amongst us today to bless us with his words of knowledge and wisdom. Thank you so much, sir, for sparing your valuable time from your busy schedule and gracing the occasion with your presence. With this note, now I invite Dr. Himanshu Monga for his address. Over to you, sir.
Thank you so much, ma'am. I hope I am audible also. Thank you so much.
Yes, sir. Yes, sir, very clearly.
Okay, thank you. Thanks for the nice words. And I have kept the session a very brief session. I am given a limited time, so I will try to confine myself within that time only. So I hope the target audience is all well aware about the ISO OSI model. So I have kept it very simple, as I stated earlier also. So let me share my PPT if I think I am allowed to do so. So
yes, sir.
Kindly let me know if you can have access to my PPT. Can you?
Yes, yes, sir. It is visible, sir.
I hope you can see this. So as stated by me, actually, the topic is related to the data link layer of OSI model. And in that only, I have kept it to MAC protocol designing. So the broad topic is, though it is written as challenges in mobile ad hoc networking, but I will limit myself towards the MAC protocol designing only, and that too related to data link layer. So kindly, wherever you feel like you want to ask anything, you can interrupt me in between. So I'll be more than happy to resolve that, or we may discuss that at any given moment of time. So as already my introduction is given, I am from Jawaharlal Nehru Government Engineering College. This is in Sundarnagar, Mandi, Himachal Pradesh. So I hope we all know we have latest cellular technologies starting from 1G to 2G, then 2.5G, 3G systems, and then 4G. And now they are talking about next G systems like 5G also. We have various wireless LAN technologies working on 2.4 and 5 gigahertz wireless band. And when we talk about Wi-Fi networks, then we always talk about IEEE 802.11 standards and its different flavors or versions like A, B, G, and N. And this is what we talk about the wireless LAN. And we have various research topics in that. We talk about ad hoc networks. That is really a topic of research. Then we have short range technologies like home RF, Bluetooth, Zigbee, and long range technologies like internet, what we call today, like in which we also cover the WiMAX technologies also, which is IEEE 802.16 standards. So whenever we talk about these technologies, definitely we talk about the shared medium, because wireless is a broadcast medium, we all know that. And once we are talking about a shared medium, a broadcast medium, then definitely we are talking about some protocol. We need to have certain protocols. So these protocols are required to regulate the access to the shared media. That is the channel. That is what we call about the medium access control protocols are required for this. So I hope my slides are visible, and if you outline is given, but yes, I cannot have everything here. So I restrict myself to medium access control layer and its designing part only. And starting from the very basic. So security issues I may or may not be able to touch. And this is what the outlining will say. History, I won't touch much. But yes, what is ad hoc network? We all know the network of wireless nodes. The nodes may be static, or these nodes may be mobile. So ad hoc networks are employed in maybe wireless sensor networks also, or whatever wireless systems we are having, whatever wireless system we wish to design. We do not require any fixed infrastructure for it. That means no base stations, no fixed links, routers, nothing is required. Data can be relayed by the intermediate nodes also, nodes only. So this is something which is ad hoc network is, and everybody is well aware about the ad hoc networks. So I will not waste much time on this. So let us go further, and and I take you to the application part. Is also, I think, very much clear to everybody, because we have the military environment, the emergency operations, personal area networking. Every single application we talk about, and there comes the applications of wireless systems. So it can be ad hoc networks also, and other type of networks also, as discussed earlier. So as I said, we will be talking about. I will not go into the physical layer. I will not touch the wireless standards that I told, 802.11 wireless standards. I will not go into that, but I will definitely jump into the medium access control protocol. That is the task of data link layer of ISO OSI model. So let me talk here why we require MAC protocols. As we all know that wireless channel is a shared medium, and bandwidth is a very scarce resource for all of us. So we need to effectively use it. So we need some access control mechanism, something to avoid the packet collision. That is, the data should not collide. And we all know that data collision will lead us to the throughput will go down, and that is what we do not want, and delay will go high, and even the jitter part will go high. So that we need to avoid, and that means we want some better quality of service. So for having that better quality of service, we need to have some MAC protocol, some mechanism, so that we can regulate the access to the shared media. And that means the maximum probability of success, that I said, is the quality of service. It has to be there, certain minimum quality of service, so that we can have the uninterrupted services, to avoid problem due to hidden and exposed terminal. So hidden and exposed terminal is something, because I'm talking about the MAC protocol designing for wired as well as for wireless systems. But once I say wireless systems, then wireless systems, they are having two additional issues involved. One is the hidden terminal, and second is the exposed terminal. These two problems are related with the wireless systems only. So I think everybody is knowing this thing, but yes, we can at least discuss it before we can talk about the latest MAC protocols designed for today's wireless systems, or whatever is the research field coming ahead, so that every coming budding researchers, they may jump into this field and they may work ahead on this field. to maintain fairness among the users. So this is another another part of designing a MAC protocol, is that whatever we have to be very fair, because no node should be favored. That means it should not be like that one base station, one node which is closer to the base station is being favored by the base station. So your protocol should be taking care of this also, that there should be fairness among all the nodes. So no node should be favored by any system. Like base station should not be favoring any of the single nodes. So there has to be a fair system of resources allocation. So I will again skip this part because I'm talking about the distributed random access protocols. And the first, I think everybody is well aware of this, is the first protocol that was tried was pure Aloha MAC protocol. It is a very simple protocol which says that there is no discipline involved. In this picture, I think this is visible that 4 stations. Whenever there is any frame or any packet or any data that is available for any station to be transmitted, it is transmitted as such. That means there is no discipline in the protocol. So this was the very first protocol which was designed. This was the very first MAC protocol, medium access control protocol, which was named as pure Aloha MAC protocol. And I think, if going by the history, this protocol was there is a place at US, that is Hawaii, which is made up of many islands. And at that time in 1970s, they had this option of going for satellite communication. That is one form of wireless communication. And these islands, they wanted to have some sort of communication going between them. So then they designed this protocol. And as we have seen, and as we have studied in the books also, that because in pure Aloha there is no discipline involved, as and when the frames are generated, they are transmitted. Like 4 stations, they are transmitting their frames as and when they are generated. So you can see the shaded areas are the areas where the packets from the, or you can say the frames from the different stations, they are getting collided. And we all know that whenever there is a collision, then obviously the data packets, they will be lost. That means once they are collided, the data is lost. That means the throughput will go down. So this is there may be the communication failure here also, and that means there will be more of throughput will go down. So this is like in the shaded region. In the down here you can see the collision duration is shown, and this collision duration, we are getting the packets getting collided. And once these packets are collided, the throughput will go down. So this is hence it is written also, frames are transmitted as and when they are generated. So in the very first MAC protocol designed, that is called the pure Aloha, there was no discipline involved, but yes, some sort of communication, because if you go away from the shaded area, you can see some frames where there is no parallel or simultaneous frames being transmitted by other stations. The some form of communication was happening there. So so I will not go into the modeling part of it, because modeling is very simple, and it is available in the books also. So the modeling part I will skip here. And the ultimate thing is that the throughput of this pure Aloha MAC protocol was calculated, and once it was calculated, it comes to be around 18%. So the maximum throughput which we could achieve with the help of this pure Aloha protocol is calculated, and it is found to be 18.4%. Right. So first protocol that was designed without any discipline involved was the pure Aloha. So MAC protocol, I hope everybody is clear that MAC protocol is designed. There was a purpose for designing, and this purpose is solved a bit by pure Aloha type of a MAC protocol. And yes, it can be modeled very easily. And modeling part I'm not covering, because many books they are there, you can easily refer to that. And similarly, the when you can see the G is the when I take it, the G part, okay, this is the offered load. When the offered load is 50%, then the maximum throughput which was achieved with the help of pure Aloha type of MAC protocol was 18.4%. Right? Why this much low? Because our effort is to get the 100% throughput, definitely. But 100% throughput is a theoretical term which we can only which we will cover in next slides. But yes, there is certain condition. If we want to go for 100% throughput, then definitely we have to pay certain expense for that. We have to do certain things extra. So this was the first protocol, and the maximum throughput was achieved as 18.4% only. It was one attempt towards 100%, so I can say that. The second protocol which was designed after this was the slotted Aloha protocol, MAC protocol. So in slotted Aloha, the time duration, as we can see here, was divided into slots, time slots. Hence it is called as slotted Aloha MAC protocol. So in this, some sort of discipline was introduced that now the stations, they can generate their packets or frames at any time, but they are restricted that now they can transmit their frames only at the beginning of the slot boundaries. So this is what we can see here, that slots are now, the timing duration, the time axis is now divided into slots. And like we have 4 stations, as seen earlier also, the 4 stations, they have to transmit their frames, but now some discipline is introduced into this protocol, and like this, now the collision duration is now reduced, because now frames are being transmitted only at the slot boundaries. So it is written also that frames are transmitted only at the slot boundaries. That means now some discipline is introduced. After introducing this type of discipline, some discipline I can say, now we have seen that the collision duration is now reduced. Sometime it is reduced. So by designing or by modeling this type of protocol, slotted pure Aloha type of a protocol, MAC protocol, the throughput has gone up and now it is doubled. You can see it has come to 36.8%. So, and when the offered load is 100%, when the value of G is 1. So it is shown this way also. You can easily see the pure Aloha and the slotted Aloha. By introducing this much of a discipline only, the throughput, which is shown here, the throughput has become now 36.8% when the offered load is 100%. Right. So I hope this is something which was the history. Then comes the carrier sense multiple access MAC protocol. Right. CSMA protocol, it is used, and we have seen that the maximum throughput which we could achieve with the help of pure Aloha was 18.4%. With the slotted Aloha, it was 36.8%. But yes, our effort is towards 100%. Right. So it was thought that why cannot we bring some more discipline into our protocols? So like what we human beings in a conference room or in a meeting place, what we do is, before we speak something, we listen to other speakers. So this is what is thought of, and then this is what is introduced in the design protocol, that is called the carrier sense multiple access protocol, CSMA MAC protocol. That means listen to the channel. CSMA protocol says that we have to listen to the channel before we transmit a packet. That means now some better discipline is introduced into the system. So CSMA improves throughput compared to earlier Aloha protocols. So definitely once we have this type of discipline going into our protocol, then definitely this is our tendency, that once we find something better, we go for more flavors or more versions of that. So CSMA has different other versions also. One is called the non-persistent CSMA, one is the persistent CSMA. Then both are further divided into unslotted, non-persistent, and then slotted type of systems. And this persistent CSMA is further divided into one persistent and P persistent. So I hope I will not go deeper into this, because we all know what is the meaning of persistent. Persistent means constantly pursuing. So because once we are sensing a channel and the channel status is found to be busy, then even the node will then constantly pursuing, it will constantly check the status of the channel. So this is the meaning of persistent CSMA. And non-persistent means once the channel is found to be busy, then the node will not try to again check the status. That means it is not constantly pursuing that. I can say intermittently pursuing that. So then comes the CSMA CD technique. That is the collision detection. So once we can add something, CSMA means once if we can add to the collision detection capability to our this carrier sense multiple access techniques, then definitely we can avoid the collisions, and then that way we can increase the throughput. So this was first standardized by the IEEE 802.3. So I hope 803.3 is what we call as the Ethernet, is known to everybody. So Ethernet is the, we today very well call it as the wired Ethernet, or maybe the higher versions of it, gigabyte Ethernet, or maybe the fast Ethernet. So IEEE 802.3, it is very popular. This is the CSMA CD, because now we are adding the collision detection capability also to our designed protocol, that is the carrier sense multiple access. I hope I will not go into the history that this later CSMA CD, then that one company is there, that is 3Com company, and this was later sold, right? So this is all history. I will. So now coming to the wireless systems, why we cannot use CSMA or CSMA CD in a wireless LAN or ad hoc networks? Because in the earlier slides we have seen that with the wireless scenario we have two major issues. One is the okay, we'll go later into that, but yes, the carrier sense multiple access, I haven't discussed it. Now CSMA's technique says, and that before a node transmit anything, right, it has to sense the channel, and if the channel is busy, or maybe if the channel is busy, it has to wait for that wait for its turn to transmit the data. If the channel is idle, then only it will be transmitting the frame or the packet. If the channel is busy, it will have to wait for the random time, and that random time is calculated by the BEB algorithm, which is called binary exponential backoff algorithm. So this is what we say the limitation of carrier sensing is the hidden terminal and the exposed terminal problems, which is only available in the wireless scenario or maybe the wireless conditions. So because we all know that CSMA, carrier sense multiple access, and carrier sense multiple access collision detection technique is doing wonderful at Ethernet level, or what we say IEEE 802.3 standards, but we cannot apply this scheme as it is in wireless scenario because of these two limitations. Because in wireless scenario we have these two problems. One is called the hidden terminal, and second is the exposed terminal. Right, I'm going fast because the time limitation is there. So let me allow for that. So hidden terminal problem. I hope you all know this. What is hidden terminal problem? Because in the environment, of because if we say that we have the radio coverage range of 3 nodes, and the 3 nodes, one node is transmitting, node A is having its own coverage range, which is covering the C node also and the B node also, right? So node A can hear both B and C, but B and C cannot hear each other, right? When B transmits to A, then that means C cannot detect this transmission, right? Because what CSMA says that before transmitting we need to sense the channel, right? But now what happens is that because B is transmitting to A and it is outside the coverage range of C, so C may also start transmitting its data. So there may be a situation where this is one of the wireless scenario. So otherwise there may be the data collision, and if there is a data collision, then I hope everybody knows the hidden terminal problems happening with the wireless scenario. And because of this, because C before transmitting any packet, it will first sense the channel as per the Csma Cd technique, or you can say Csma protocol. So Csma protocol, according to Csma protocol, because C is not knowing about the data which is being shared from B node to A. So what will exactly happen, that it will also may initiate the transmission, and it will create a threat of data collision. So once there is data collision, then definitely there will be loss, or maybe the data packet may get lost due to this data collision, and hence we may be having lower throughput, right? So wireless scenarios, they are so similar is the exposed terminal problem. In the exposed terminal problem also, what happens is, because the bandwidth is not utilized properly, right? So because A is transmitting to B, and there is a scenario in which the transmission range of A is covered by the C and B node also. When A transmits, that means B transmits some packet to B. C detects the transmission, right? Because it is in the radio coverage range of A also. So, and it is now refrained from making any communication to another node. So in that way, the bandwidth is also not utilized properly. So it reduces the bandwidth utilization, and hence definitely reduces the throughput also. So another possible solution, or another protocol change, or maybe something was introduced by another scientist, you can say, then that was the possible solution to this is, in the wireless scenario, is to use the control packets, or you can say the control signals. So we are using control signals like RTS or CTS. So somebody introduced this MACA also. MACA is multiple access collision avoidance. So forget about the CSMA. Somebody suggested that we cannot use CSMA CD in the wireless scenario. So let us go for another system that is called another protocol, that is the MACA. So MACA says that before we actually, rather I can say, we are not bothered about sensing the channel. We will initiate the data transmission only once this control channels or control signals. So control channels are allocated in this. The control channels are RTS and CTS. So in that we have these control channels. One is RTS and then CTS. So we are making handshake signals. We are using handshake signals so that we can mitigate the effect of hidden terminals. Hidden terminals, how we can do that? It is shown in next slides. So data terminal duration. That means for how much time the data will be transmitted from the transmitter to receiver. That particular duration is also decided in the or it is communicated to all other nodes in the RTS and CTS control signals, right? Which states other nodes, connected nodes, to remain silent for that particular duration. So it will be very clear if we can see the next slides. So if a RTS CTS packet collides, so this is one issue. Still one issue is there, because RTS or CTS packets may also collide. That means then again, for that period, that the nodes, connected nodes, they will have to be kept silent for certain duration of time. That is again calculated with the help of BEP algorithm, right? So drawback is that we cannot avoid the RTS CTS control packet collision, right? So otherwise, whenever there is collision, so this is something which is shown here, that for example, A is having its coverage range, right, and B is having its coverage range, and A is the source and B is the destination. So in this particular protocol, the A is whosoever is the source node is not bothered about sensing the channel, right? So it is transmitting the control signals, and the control signals is RTS signal. So RTS means request to send. So RTS signal is broadcast to every single node available in the network, in the wireless network, and every node, like in this case, A is the source node. So nearby nodes like C, D, and B, because B is the destination node, all the nodes, they are getting the RTS control signal. RTS means request to send. So every single node in the vicinity or in the coverage range of A will be broadcast a RTS packet, right? So B is the destination, so definitely it is also getting the RTS packet. So likewise, once it receives the RTS, so as I stated earlier that RTS and CTS, these control signals also having the duration, that for how much duration of time the data will be flowing from source to destination. So once it receives, so the B will be broadcasting the CTS to all its neighboring nodes. Right. So similarly, as is shown in this slide, the B is giving a response to the RTS packet received or RTS signal received by it by broadcasting a CTS signal. Right. These are the control signals. And once this has received by the A, then only the data will be initiated. Data exchange will be initiated from node A, which is the source node, to the destination node, that is the node B. I hope I am audible, and is there anything to ask? Because
Yes, sir, you are audible.
okay,
Please continue.
Thank you. So then later somebody suggested that yes, what is the guarantee that data is transmitted? So because in communication we always talk about the link reliability also. So the only change in this protocol was introduced, that was that after the link is established, the data flow is established from the link from the source node, that is A node, to B in this case, then the acknowledgement signal, once the data is transmitted, that means the B node will be transmitting the acknowledgement signal also to the source node. So this improves the link reliability using the acknowledgement signal. So this is called MECA for wireless LANs. Right. So yes, later IEEE 802.11 standards for wireless systems, MAC protocol. It is mainly has the provision of two modes. One is the point coordination function, and second is the distributed coordination function. So point coordination function, that is not that there is no problem as such, because we have one centralized access. There is centralized access. Control is there. That means some base station is there to take control of every single identity, single communication happening. But in distributed coordination function like ad hoc networks, we need to take care of these things also. So point coordination function, as it is written, it provides contention-free access. That means some central access system or access point is there that is taking control of the coordination among all the nodes. So definitely it is not suitable for managed systems also. So now we are talking about the distributed coordination functions. I told because this is something which is challenging also, and this is because no centralized access control system is there. So we are basically having two schemes. Now one is the basic access scheme, that is Csma Cd, and second is Csma Ca with RTS and CTS. But that means our network administrator has to be very, very sure about the hidden terminal or the exposed terminal problems happening in the network. If there is no issue or no scenario in the wireless network, then one can have only the basic access schemes or maybe the protocols applied in their network. But if we are having doubtful, or if there is the scenario of these two particular problems happening with the wireless systems, then definitely we have to go for Csma Ca with RTS and CTS, as we have seen. So like in this particular slide, definitely I wish, because C is first, because we know that RTS signal is traveling to D, because data is to be transmitted from C node to D. That means there is a request to send type of a hand-shaped signal going, and once it goes, because B is in the coverage range of C, so 1 NAV, that is called the net allocation vector, which indicates the remaining duration for B, for the duration for which B has to keep silent. That means it cannot make any further data sharing. It cannot share data with another nodes. So this is what the role of RTS CTS is, CSMA CA with RTS CTS. And once this happens, then D will be sending the CTS signal, because it will sense that now there is no carrier sensing happening. And what will happen, that D will, the neighboring node to D, that is E, it will get the this is 15 is the duration of time, or we can say the time duration for which the neighboring node, in this case E, will have to be kept silent, right? So before having this acknowledgement signal, data packet follows the CTS. Successful data reception is then happening between C and D, and then the acknowledgement is coming back from D to C, right? So we are taking care of this protocols, and there are certain limitations of this also. And I will again skip this part. I will go to yes, what is the solution to this is, we can use the directional antennas rather than using the omnidirectional antenna, to avoid the hidden terminal problem in happening, hidden and exposed terminal problem happening with the wireless scenarios. So we need to take care of these directional antennas. They are working energy conserve. Okay, once we are designing the protocols, maybe the wireless sensor networks, we are designing the wireless sensor networks, and we have to we are designing, we have to keep certain things in mind, because once you are designing the wireless sensor networks MAC protocols, you need to take care of additional things also, because we need to conserve energy also. So whatever computational powers your algorithms, maybe the MAC protocols, they are taking care, these are they should not be very complex. Once they are complex, then definitely they will be consuming more battery. So for wireless sensor networks, we should be very careful about the energy also, right? So, and we need to know that whenever the battery is not being whenever the particular nodes is not transmitting any data, or it is not sensing anything, it should go into sleep mode. So I said the battery conservation is another point. So I said energy conservation while designing any MAC protocol, we should be focusing on the energy conservation also. So this is application specific also. And second is that security aspect is also required to be taken care by the MAC protocols itself, right? So energy conservation is, I said the power control, it has to be there. So we have to have certain power aware MAC protocols available with us. We should be knowing that. So many protocols, routing protocols are there. So routing protocols, importance, I know the mobile, this MANET, the importance of routing in MANET is there, that host mobility, the link failure due to mobility of nodes, then this has to be taken care by the designed the protocols also, right? So because the mobile, in MANET scenario, the nodes, they move very fast. So we take the we have to be very much. We have to take care of the rate at which the link failure is happening in your network scenario. So definitely there are classification also. You may have worked on this proactive, active, and the hybrid type of this unicast routing protocols. Many are very still used, still being used nowadays also. So these are something which you can model also. You can design it, because there are many simulators available, I suggest. So ultimately, first you need to test whatever is your designed MAC protocols are. You can use a simulator first, And then once you are successfully tested your design protocol on any given simulator, then you can design your own prototype, and you can implement it in any operating system also, right? And then later, once you have got the successful results, then you can test it in real test beds also, right? So similarly, we have the proactive type of routing protocols. I said depending upon the need, we can design the different type of protocols also. I'm not going much deeper into, because later we can see how this AODV or DSR protocols they are working, DSDV protocol are working, because these all we can make certain changes also in our scenario also. And if you have any good simulator available with you, maybe the QualNet or OptNet or maybe NS2 or 3, which are available online without any cost, so that can be tried. And these are some characteristics of proactive routing protocols. So I told that DSDV, that is the destination sequence distance vector type of protocol. DSDV MAC protocol is also available, and one can try this, because students they work on this. The master's level students they are working on it at our institution also. So reactive and proactive. The earlier slide shows that proactive. Now I'm talking about the reactive routing protocols, and similar is the characteristics of reactive routing protocols also. So reactive protocols, they determine the route if and when needed, right? So they're determining the routes, and as per their need. Then these are the highlights, that less control packets and less overhead is there. So if I compare DSDV with AODV, so depending upon the specific application, because ad hoc on-demand distance vector routing protocol is something, because the route is discovered in this particular algorithm, the route is discovered whenever it is needed. So I said in this case the control packets are, the overhead cost is reduced, that means packets are less, right? The control packets are less. So this way latency is another thing. Then we need to take care of that. Overhead is another. So similarly, there are transmission control protocols also. So once we go deeper into it, you will find some motivation going further into these type of protocols and designing these protocols. And later, this is something which is a research field, right? And wireless systems, they are still you can say many topics are there. So we can work on maybe the security aspect. We can work on the many topics in between, whatever you want to try. So I think the time is less. So if you can tell me if the time is less, then I will stop here only. Ma'am?
Yes.
No, sir, continue, please. Continue.
So definitely that TCP protocol is also there. So packet losses are avoided, and we all know that impact of transmission errors in TCP protocols. So there are certain errors also, there are certain deficiencies also in TCP. So how like TCP cannot distinguish between packet losses due to congestion and mobility induced transmission errors. So I said there are certain applications in which we need to identify which protocol will work better. So once we identify that, then definitely we can further develop on that. So I said, because you have to have certain simulators available with you, and once you have your design model, then definitely you can test the designed protocols for the on that particular simulator. And once you have designed that, then the prototype can easily be tested on any of the operating system. And once that is tested, and then you can take that further into the real test bed. So I think the next is the quality of service issues, because I said once we design any wireless system, the first point is the quality of quality of service, which is different for different for different applications. So whatever is the quality of service, we have to maintain the minimum standards for that. So wireless is, again, we are having certain standards allocate minimum standards for quality of service, which we can only maintain once there is less packet loss, there is less jitter, and the bandwidth is required to be efficiently used. So quality of service will then come up. And once, because nowadays data flow is that much that we want higher quality of service, right? So that the quality of service is higher and the packet loss is less. So there has to be lesser delay also. Packet delay is also required to be less. And this is what we want. We want the propagation delay time to be less. And this is what we know, that CSMA technique or the protocol, which suggests that I can offer you 100% throughput, provided there with a one condition, that propagation delay divided by the packet transmission time should be 0. So we all know that the packet transmission time cannot be minimum, and only thing is that the propagation delay time through a channel is required to be as low as possible. So we are working on that. That propagation delay time is required to be reduced to its minimum. So that is one effort in the direction of having a good MAC protocol design and getting the maximum quality of service. So this is what our aim is. Quality of service issues and difficulties are also stated here, that these are the major issues with the MANET in wireless systems. That means the nodes, they are very, very mobile, limited battery life. I said these all are the research issues nowadays. So anybody can work in the field of mobile networks, that too on taking care of any of these issues or the difficulties in the wireless scenario. So if we can address any one of these, I said then that will become the research area. Security issue, as stated here also, that there is a security issue. Security issue is something which we should address in the wireless system. So this is something which every single researcher in the wireless domain is working hard on. So I think security issue is something available in mobile ad hoc networks, MANETs, which we say wireless system is very easy to snoop. We all know that due to it is not guaranteed that the data intended for a particular node will only be getting that information. Data is only being shared with that particular destination node only. So that is another issue, how to tackle that. There are many techniques already suggested, so anyone can have access to that. How MAC protocols they can support mobility, security, and the quality of service. So we can definitely start working on this. I think I stop here only. So thank you so much for inviting me. I think.
Thank you, sir.
Thank you. Thank you very much, ma'am. If there is any question, we can discuss it.
Yes, if anybody has any question to ask, so please you can ask, sir. Anyone from the participants? If you have any query regarding networks, please ask.
The only thing I can say is, because we have some free softwares, NS2, NS3, so anybody can try that. Omnet plus, I think that is also available. So I think there are many problems, open problems, as is being shown in the slide, right? So I said one can try this, and definitely the results are bound to come.
Yes, sure, sir. So I don't think so anybody has any query. So we can conclude, I suppose. So thank you, sir. We have been fortunate to have a renowned entity from academics, Dr. Himanshu Monga. Your presentation has made this event memorable, sir. Your presentation on challenges in mobile ad hoc networking was very informative. You gave brief introduction of cellular technology, wireless technology, short-range technologies, and long-range technologies, and importance of protocol in shared medium. You very beautifully and diagrammatically explained medium access layer, how the frames are transmitted in first pure Aloha MAC protocol without any discipline, giving maximum throughput of 18.4%, and how gradually by introducing the discipline, their throughput has been enhanced in slotted Aloha Mac protocol and other variants. You also throw light on issues in wireless technology, carrier sense multiple access with CA and CD, multiple access with collision avoidance, and how it solves the hidden terminal problem was really informative. I'm sure participants have gained a lot from your presentation, sir. You have surely added to the charm of this event. Thank you so much, sir, for the wonderful session. With this note, the technical session 1 comes to the end. So now I invite Ms. Manu for the further proceeding of the seminar.
Thank you so much, ma'am. Good morning, everyone. Greetings of the day. I, Manu Gupta, on the behalf of Sanatan Dharma College, Ambala Kent, welcome you all in this technical session 2 of one-day online national level seminar on emerging trends of technologies in current era, being organized by Department of Computer Science and Department of Electronics and IT of Sanatan Dharma College, Ambala Kent, in collaboration with Department of Higher Education, Haryana. Today, we have with us Dr. Rajesh Khanna as the key resource person for this session. Sir, we are really thankful that you have accepted our invitation to share your insights on the topic today. I take this opportunity to formally introduce him to all. Dr. Rajesh Khanna is Professor of Electronics and Communication Engineering in Thapar University, Patiala. He has more than 33 years of experience. He has a significant contribution in carrying out several research projects on electronics instruments for various industries around Ambala while working for Hartron. He also worked in All India Radio Jalandhar from 1993 to 1999. He has guided 16 PhD and 80 ME Tech theses. He has widely published over 60 peer-reviewed publications. He has also completed projects worth 1.8 crores. His various interest includes in design, development of antennas, for wireless networks. He has built up his own testing lab for testing of antennas. Dr. Khanna has interest in implementation of SDR-based wireless communication systems and testing of various algorithms on these systems. Dr. Khanna, I formally welcome you to this session today in our esteemed institution, that is Sanatan Dharma College, Ambala Kent. Thank you so much, sir, for coming. Over to you, sir.
Thank you, Manu. Am I audible?
Yes, sir.
And my screen is visible, Manu?
Yes, sir.
Okay, thank you. So I thank Sanatan Dharma College principal and Aarti ma'am and other faculty members for inviting me to this session. My session will be not related to any my own research, but it's a general session. What is the wearable technologies and what is the future of wearable technologies? So because your topic, I think, correlates with the future technologies, so I thought that it will be nice that I talk about what are the technologies which are coming up, and students and other faculty members can work in those technologies. So if you look at technology, it's basically changing for the last, I think, since it introduced, it's changing since human beings start using tools and other stone tools and other things. So it's not only changing, I will say it's accelerating basically. So this is basically a statement that technology is not changing, it's accelerating. So what are the frontier technologies which we are right now working for future? So, or what is meant by frontier technology? First, let's have a look at that. What is meant by frontier technology? So there is no single definition of this frontier technology. It's understood to be any technology which is new, rapidly changing or rapidly developing technology that take advantage of digitization and connectivity. That becomes basically a frontier technology that has a dramatic response, dramatic impact on economy and society as well. And frontier technology can increase productivity and improve livelihood also. So if you look at frontier technology, this is a definition of frontier technologies. So I will start discussing few technologies, then I will come to my topic. These technologies are not listed by me. They are basically explored by various technology experts. They have said these technologies will impact in next few years to come. The first technology which will impact the life of a human being and will impact society, that is basically 3D printing. So 3D printing is also known as additive manufacturing. Produces three-dimensional object. You can produce any three-dimensional object. It can create any complex object also. It has basically made the life of every person easier. I will give you one example now. Doctors are also using 3D printing. If you want to have a dental implant, if you want to have some limb to be produced, you can use this 3D printing to have that type of thing possible. So this is one area where people are working, and this will change the life of everyone dramatically. The second technology which is coming up is robotics. Robotics is basically programmable machines. They carry out actions and interact with environment via sensors and actuators, either autonomously or they can be controlled also. They can make many forms: disaster response robots. You can have a consumer robots, you have industrial robot, you can have agriculture robots. So robotics is basically entering every form of person or every form of life also. The third technology, which is frontier, is known as a drone technology. They are also coming up very fast. They are basically known as unmanned vehicles. They are flying robot. They can be remotely controlled also using software with sensors and GPS. Drones have been used in military purposes. They can be used for agriculture purposes. They can be used in delivery purposes. On 26th January, I think IIT Delhi has demonstrated this drone show after 26th on 26th January parade. After 26th January parade also. The next technology which is coming up is say gene editing. This is not related to engineering side, but from biotechnology side, people are working on this, or medical side. It's a engineering tool to insert, delete, or modify the genome of an organism. So potential applications can be like you can use in crops also. You can modify the crops. You can use in antibiotics also. So this is one area where large research is going, and people are this will change the society also. The next area of research which you people may be working, maybe electronics people may be working, is nanotechnology. This is again applied field of science and technology dealing with the manufacturing of the objects with a scale smaller than 1 micrometer. It produces wide range of useful products like pharmaceuticals, commercial polymers, protective coatings. So a lot of research is going on into this direction. You can think of designing your computer chip layout also using these nanotechnologies wires also. Okay. The next area of research which future technology is basically solar PV. Solar voltaic cells technology basically transform the sunlight into direct current electricity using semiconductor within PV cells. So being a renewable technology, solar PV can also be used for off-grid energy system. They potentially reduce electricity cost and increase access also. So this technology is also growing very fast, and a lot of research is going into this technology. And if you look from technology which is common to all of these, whether mechanical, whether electronics or computer science, that is artificial intelligence. So artificial intelligence is normally defined as the capability of a machine to engage in cognitive activities. So any machine which can do cognitive activities like a human being or human brain, that is artificial intelligence. So AI implementations focuses on narrow tasks are widely available today. Used, for example, in recommending what to buy. If you are using AI, if you use your mobile phone, if you once you Google something, next time it automatically shows you that you last time did the same thing, and it shows the similar. Suppose you choose a dress, it will show the similar dresses which you chose the last time. So it can be a virtual assistant in your smartphone, spotting spam, detecting credit card frauds. So new implementation of AI based on machine learning and big data is also one frontier technology in which people are working these days. One more technology which is associated with AI is basically big data. So big data refers basically to a data set whose size is very large. So this is beyond the ability of a traditional database structure to capture, manage, and process things. So big data is basically a huge data sets. So computer can thus tap this data into traditionally being inaccessible or unusable. So earlier we thought this data is not usable. Now people have started using this big data also. And with the use of machine learning or deep learning, you can take decisions which earlier were not taken very easily. If you use manual, if you use your own brain also. The next thing which is future technology which is coming up is basically, I will say, a blockchain. A blockchain is basically refers to a timestamp series of data records supervised by a cluster of computers, not owned by a single entity. Like if you do a cryptocurrency mining, you are basically doing it on a blockchain. So blockchain basically is a cluster of computers not owned by only one person. So it basically serves as base technology for computer technology, this cryptocurrencies, peer-to-peer transactions that are open, secure, and fast. So this technology is also being a frontier technology. Then one technology which is related to communication is 5G. So 5G networks are basically next generation mobile interconnectivity. You can connect devices, you can connect phones, you can connect street lights, you can connect cars. So everything will become connected using this 5G communication, and data rate which is being supported in this case is around 1 to 10 Gbps. So it's a huge data rate as compared to 4G, which was only offering you 100 Mbps data rate. Okay. So that's another technology. One more technology which is frontier is IoT. So IoT refers to basically internet-enabled physical data. So when you want to collect data using internet and the devices which are being connected, then it is IoT. So there is a vast number of devices that are being collecting and sharing potential applications. So typical examples are smart homes, smart healthcare, smart cities, industrial automation, and all these things. So this is basically one of the main future technology which is coming up and being deployed in various sectors across society, not only industry. Various sectors are using this IoT. The last thing which is being used as a frontier technology is basically a combination of IoT and 5G, on which I will be speaking later on. That is basically wearable. So wearable is basically a technology or category of devices. They are basically body-worn computers, and with sensors. They can be implanted in your body also. They can be even tattooed on a skin also. So they intend to interact with the wearer without punching keys or either manipulation. So they are always working, always on. They perform certain calculations and process information and send that information back to the user or to some other person also. So we'll discuss this later on. So that is one area which is also growing very fast, wearable technology. So if you look at all these rapidly growing technology, these are 12 technology which are rapidly growing, and they represent a 350 billion market by 2025. And today they are representing 350 billion market, and which can grow up to 3.2 trillion. Not today, it's basically 2018 prediction is there. So in 2018, these 12 technologies gross in revenue was 350 billion, and it is expected that it will touch 3.2 trillions by 2025. Okay. So if you look at the sectors which are using these technologies, earlier adopter of these technologies are basically, I will say, 3D printing, robotics, finance is one sector, manufacturing sector is another sector which is using this. So finance and manufacturing sectors were earlier adopters of this AI, IoT, big data, and blockchain. So if you look at these technologies, so AI, IoT, big data, blockchain, finance and manufacturing are basically big sector which are using these technologies first. Other sectors are also coming, like pharmaceutical and other sectors also. And if you look at the providers, main providers are basically American companies, which are shown blue in this diagram. So all these are American companies. Chinese companies are in orange and others are in gray. So if you look at these, the providers are basically American and Chinese companies only. Okay. So these are the top technology providers. And if you look at number of publications by these frontier technologies, I think this is data from 1996 to 2018. So the two major players in this case are again America and China together. So they are basically holding 30 and 70% of share in each of these technological fields. Okay, so this share shows here. So you can see that the America and China are holding the major share of these publication also. And if you look at patents also, patents are also like US and China are basically holding the major chunk of these patents. Now, any front-end technology is basically defined by its readiness index. So how much ready we are ready to use that technology, that is defined by its readiness index. So it basically contains its ICT deployments, skills, R&D activity, industry user, and ACE. So access, sorry, not access, this is basically access to, not access to finance. So these 5 are the controls which basically allows you to use, adopt, and adapt to these frontier technologies. And if you look at the data of which is available on these 5 indexes, which is calculated across 158 countries, including India also. So this data shows that how we are ready in this. So total ranking, US is first, second Switzerland. But if you look at R&D ranking, India is somewhere at the 4th position in this case. So India, I will say, is only going ahead in R&D ranking. Otherwise, we are lagging behind in other rankings of this. So we are not taking ICT training, skills ranking, and other ranking of these type of things. So that's a basically challenge for India, that how we can be ready for these adoption of these frontier technologies in our countries also. Now I'll come to my topic, because I'm basically focusing on wearable technologies. So if you look at health innovation framework with emerging technologies, it involves basically all technologies. It involves 3D printing, it involves mobile health, artificial intelligence, big data, IoT, Internet of Medical Things, robotics, wearable, 3D imaging also. So AR, VR, augmented reality, virtual reality, all are becoming a part of these wearable technology. So wearable forms basically an important future technology. And let's have a look at this growth of this wearable technology from healthcare point of view. So wearables are basically not new things we have started. Wearables basically started from the basements of 70s, when the computers were put in the basements of the various big houses. Then from basement they came to the desk of the person, then from the desk to laptop, and from laptop to pockets, and finally they are now they are being put on the body of a person also. So I'm showing you first picture of a computer which was put in a basement like this one. So this is a huge computer system which is in a basement of a room, but slowly we shifted. We eventually made it smaller, but it was still separate. If you see, mobile phone is still separate. We carried a separate phone. Our next step is basically to start make this technology a part of us, something we can wear also. So that's basically our target. And yes, we are headed toward this. So, and it began in 2014 with 19.2 million of wearables, and in 2018 there were 101.9 million of wearables present. So if I ask you one question, is wearable technology new? The answer to this question is, I think, no, wearable technology is not new. Anyone who has seen wearable, not you people, maybe young, any faculty member who has seen wearable before being used in day-to-day life? Anyone? can raise hand. So anyone who has seen the first variable? Manju Gupta? Yeah, ma'am, can you answer if you are allowed to open your mic?
Yes, sir. Sir, I
Can you
think smartwatches from Apple.
No,
Those
no,
are
no.
variable
I saw the
technologies.
first variable ever. Where did you see? I saw the first variable in
Okay.
a film by Anil Kapoor. If you remember, there was a film by Anil Kapoor in Mr. India.
Yes, sir. Yes, sir.
So you remember that film? So he showed that when you press a button, he can be activated. He can be invisible to a naked eye also. So this was the first variable I saw in the
Okay.
movie Mr. India. And after that, 2 years later, in 1989, Future Part 2, where you can have a connected Googles to watch TV and make video phone calls. So this was another movie. Then finally, a movie. A visor from StarTech. This is a device that helped to see even blind people also. So we basically saw these things in movies only. But if you see the history of variables, it started from your eyeglasses. Eyeglasses is the first variable we use, then pedometer, hearing aid, and so on. So I'm not spending time on this. There's a lot many variables which we use, but we never thought of these are the variables. We thought that something which can be tied to our hand is a variable, but all these things are variable. Sony Walkman we used. Many people of faculty member might have used Sony Walkman also. So these are all variables which now they are Bluetooth headsets, GoPro, Fitbit Ultra, Pebble Watch, Google Glasses, and so on, other things also. So these are basically variables we used using these days. And if you see the history from 1980, healthcare variables, we started as a heart rate, chest straps, armband, calorimetry in 2000, then GPS activity trackers in 6 to 9, then mobile tracking apps developed in 2010, then 12 connecting vital signal monitors also from your body, then wrist arm activity trackers were developed, then integrated solution for smart devices were developed, compelling using cases, wearable tech. Basically, after this wearable technology proliferated this everybody's life, day-to-day life. So if you categorize these variable health applications, they are basically categorized in different domains, like you can use for cardiology, pediatrics, obstetrics, nanotechnology, oncology, neurology, psychiatry, and stages can be, you can have for prevention, for diagnosis, for treatment, and for rehabilitation also. So any stage you can use this variable application, variable devices, and beneficiaries can be anyone starting from a baby to a medical practitioner, a caregiver also. So that's also a beneficiary. So these are like different domains like medical practitioners, persons, older adults. So all are using these wearable devices these days. So if you look at the growth of these technology, wearable technology, which is happening these days, now computers are being worn as a garments these days. So we basically worn computer as a garments. This bring technology close to the user. This basically help to support, facilitate, enhance daily activities. This also augment human sense, raise user awareness, empower them. Diverse application domains are there, and to support this, what we need basically is a smart wearable these days. So wearable and smart wearable are totally different things. If you have some computing facility also available with your wearable, then it becomes a smart wearable. So people are now talking of this smart wearables. So in next future, we are now talking of smart wearables, which can help you in maintaining all these day-to-day activities, your health also, and other domains also. So if you look at smart wearables, people started using these smart watches to monitor their health, sleep quality, chronic conditions also, how many sleeps per day, workouts, heart health, calories burned, sleep quality, stress levels, then possible COVID-19 symptoms, chronic health conditions, other also. So this is type of wearables we are using these days. So the purpose of smart wearable is basically to not only to give you all these parameters, but it also send these parameters to doctor. So doctor can see these parameters and can prescribe you medicine also and other things also. So now we are talking basically talking of terms where your device is connected to a medical practitioner also. It can be connected to your parents also, to your house also, and so on. So this is basically wearable is acting as a motivator to a person. It is basically helping doctors to identify any or diagnose or prevent anything which is possible for a person. So what we are now designing is basically devices which quantify a person. So it can be in the body, it can be on the body, or it can be close to your body also. So all these type of activities or all these type of sensors or devices we want to have in our day-to-day life. So we want to quantify ourselves in terms of tracking, in terms of use, in terms of diagnosis, in terms of prevention, everything we want to do with these type of devices. So if you define these wearable devices, I will say IoT has the one potential which IoT basically gave the potential to these wearable devices. So also the breakthrough in the cost of sensors. Then Goldman Sachs in 2014 predicted that connected wearable devices, connected cars will be there. Then data from these devices can be collected and analyzed using various artificial intelligence algorithms. It can give feedback to a user. It can give feedback to doctor, to the device itself. So new smart devices, wearable devices are launched every day. And if you look at the model, it's basically wearable. User is wearing this, and then the data is being sent for processing unit, and this is being fed back to the wearable once again. It can be used by doctor also, and so on. So this is a conceptual model of a smart wearable. And if you look at the growth of this market is going tremendously. The compound annual growth rate is around 15.8%. Okay, and if you look at being two different smartwatches and wearable medical sensor, the growth of these two are also very fast. And by 2024, we are expecting 11% growth in smartwatches and fitness trackers and 90% in wearable medical sensor and devices. So growth of wearable medical sensor and devices is very fast. What's the reason of this growth? If you look at why wearable market is growing, because we have now 1 billion connected places are there. We have 5 billion connected people are there by 2010, and by 2020 we have 550 billion connected things are there. So when things are being connected, the growth of this wearable technology is very fast. Second thing which is possible for this wearable technology grow is sensors. We are now having very miniaturized sensors using MEMS technology, which can offer real-time connectivity to service provider. It is basically 24x health monitoring is possible. So we can have all type of sensors, sight sensors, hearing sensors, smell sensors, taste sensor, touch sensors. So all these sensors are basically bringing increased functionalities to the sensing which is possible previously. So this is possible due to all engineers which are working in this direction. So if you look at the roadmap of these sensors, they are divided in 4 parts. Phase 1 was only accessory. Phase 2 is it is now coming on textile and fabric also. Phase 3 they are patchable. Phase 5 now we are working towards implantable sensors also. So body implantable, low weight, self-sustain. So people are working these areas these days, and by 2025 you can have implantables. Implantable are right now also possible, but it will be freely available to all the person to use these implantable sensors. I will discuss this later. Then 5D has made this thing possible because of its high speed, high connectivity. It's possible to have your signal possible in even in a area where there is less signal strength is there. Okay. So if you look at the driver for this is basically we are now talking of point of care to everywhere care. If I'm not at home, I am anywhere in a town, in a world, my care should be taken by my doctor. So that's my target now. So instead of hospital care, everywhere care is the target. Okay, we are targeting this. Then we are also targeting that these data should be transferred very fast using 5G 6G communication. So a level of integration is very fast between these two things. So wearable and mobile care both are integrated very fast. Okay. So wearable has become a part of your Internet of Things wave, and everything is connected. You can get a feedback possible from your devices to doctor, doctor to devices, and so on. So doctor at his clinic can see what is happening to you, whether you are having a right sugar level or not, whether your BP is right or wrong. Then he can prescribe you some medicine immediately. So that's basically we are targeting with these visible devices, with these wearable devices these days. So if I divide them into different areas, wearable devices are basically for infotainment, industry and military. Fitness and wellness is one thing, and lastly we are having healthcare monitoring, which we are talking right now. So healthcare monitoring is one of the major area of this wearable devices, smart wearable devices. So monitors wearable patches, drug delivery, continuous glucose monitor, other healthcare applications. I will show you few application of these devices. One is basically Sensoria smart socks. So these socks are insulated and with proprietary 100% textile sensors. So they are paired with a Bluetooth, smart cool and detachable core that not only basically delivers superior accuracy in step counting, speed, calories, altitude and distance tracking, but goes beyond that to track cadence, foot landing technique, impact skew generated as you walk and run. So this type of sensors are being embedded into your socks. Then we are another sensor which is used for jawbone activity monitor. So this jawbone is a basically slim and stylish fitness tracker. This is advanced feature like NFC payments possible, sleep tracking, bioimpedance sensor for heart rate is possible. Similarly, we can have another sensor which is a foot logger. So this is shoe sole for tracking. So you can have a 8 pressure sensor, 3-axis accelerometer being put into your shoe to monitor your activity levels, walking health issues, energy expenditures, therapy progress, onset of dementia or falling problems with people, with elderly people. So this is again a very new type of area where people are working towards, where elder people become generally alone after when their children go away and when they become old, they suddenly fell in somewhere. So there is nobody to take care of them. So we are also designing some sensor in this area so that we can take care of elderly people which are staying alone. So this will act as a caregiver to a person. Then there is another sensor. This is a Memo. We call this Memo, baby status monitoring. So it basically, if your infant is at home and you are working somewhere else, then this monitors baby activities like how the baby is breathing, and it comes from a fitted grip sheet as a crop to a variable. So you can think this is the sheet which is cropped to a variable, and it sees whether the baby is awake, whether baby is upright, whether he has rolled on something or not. So this type of variable sensors are also coming. I will show you one more sensor which we are also working in this direction. So this is basically a flexible wearable sensor which can be printed on the skin. We call this as e-tattoo. So it can collect certain information and can send to the database. So that is a type of sensors on which people are working. So do consumer think that wearable tech time has come? I think it has come. So where will be after 4 years? So if I ask you, this is all available right now also. So if I ask you where will be after 4 years, I will say smart wearables has a long range to take, but growth is very slow. I'll show you one case like there is one thing like intelligible safe driving internable is there. If you swallow a capsule, so this is a pill sensor you swallow, it measures your blood alcohol content, and such this pill will communicate with your car whether if your level is okay, it will allow you to a car to start, otherwise the car will not start. So this type of sensors are also done. If a person is going outing and takes some alcohol, then after taking this pill, the car will not stop. So the wives who are worried about their husbands, if they drink and drive a car, so this pill will be very useful for those type of for those wives also. And then there is personal temperature control therapies there. Like these are the shirts which these persons are wearing are basically having sensors. So when they are doing exercise, temperature rises. So there is automatically cooling being built into them. So a bracelet measures internal temperature. This produces cooling or heating sensation on the wrist. So adjust temperature across the whole body through this shirt which they are wearing. Then there is connected togetherness for transforming touch wirelesses. So like there is a skin patches there, like a tattoo sensor I told you. So depending upon your mood throughout the day, it will ask you to do deep breathing in stress or anxiety. You can share this data with others also. So this type of tattoo is also done. Then there is a glucose monitor I told you. These monitors like continuous, they keep on monitoring your glucose levels for diabetic patients. So these levels help patients to monitor and keep informed about their choices of food, physical activities, and so on. So there is no need to prick your finger every time. Then there is again a smart sensor which is developed for a child, whether this is called as a Monit smart diaper. So the child, whether he has done pee or poo, this device will tell the person, the caretaker, that whether the child is having pee or poo, so that it basically reduces the effect of UTI and other diaper rashes also. Then there is a device which is developed. This is a device which is connected as a sensor. So this device uses ultrasound to monitor the pressure of a bladder, and then it asks you to go to the toilet for releasing that pressure. So this type of devices are also being developed. Then there is another device, Dream On. So how fancy, whether your sleep sounds little weird. So Dream On is basically helps you in going to a deep sleep. It basically emits some sort of pulses, low frequency pulses, which order to lull your brain and ask you to sleep. So if you look at future vision is totally different from existing outside our bodies. Now we are going inside our bodies. So I told you in 2025, you will be having pills, implantable pills also. So what we want to believe after this is basically a smart dust. So this is smart dust is basically small nano devices called modes. So they attack on early cancer cells. So if we can swallow these devices, and they will attack on early cancer cells, or closing or bringing the pain relief to a deep wound also. So these are the small sensors with antennas, full computers, array of computers. Then there is a pill. This is called as a verified self. So this technology could be used for every single human. This is basically ID for a symbol, every human being. So for US military, they are using this as an ID. So this can be implanted, and they can check the health of their military, their forces, where they are moving. So they basically have all the information about their military personnel using this device. Then there are 3D printed organs are coming up. We can make for already made skin for patients with burns, skin ulcers, other coronaries, livers are there. So idea behind tissue engineering is that you take a piece of plastic 3D printed on desired form, add human cell to this, put some special media into the mix, and while you have just become a god. So just now you have ability, skin, bone, tissue, any organ in the human body you can simulate, and you can control also using putting some sensor inside this also. Then cyber pills, you can eat a cyber pill which will be connected to your doctor, and doctor can see what is happening inside your body, and he can prescribe you medicines also. Then there is one more, healing chipset is being developed. So scientists in London are developing this, which basically monitor your fat levels and can control these fat levels also. Then ecoskeleton is developed. This is developed for military people, not related to sensor, but sensors are being used into this. So it basically helps military people to carry huge weight on their body. So this is a tea jacket, parents to calm their kids with their mobile phone. So this gives a haptic feedback. So power of haptic feedback to create a tangible connection between loved ones and your kids. So this is basically gives you a hug type of simulation to the child, that his father or mother is hugging the child. Then wearables technologies are embedded sensors are gathering information. So this is a bracelet which sends thermoelectric pulses to heat or cool a person's entire body, which I showed earlier also. Then there is another device which is Lumo back, which basically notifies a person, like we are now sitting 24 or 20, more than 12 hours a day on a chair. So it basically helps you to correct your posture also. Then there are zoomable lens also, which are closely aligned, even integrated within human body to enhance existing perception also. So if you look at 2022, the major trends which are coming up is making healthcare totally remote, taking healthcare at home, trustworthy AI, embarrassing advanced telehealth, promoting diversity in healthcare also. I will give you one example where we people are working, like we are designing electronic system for like sometimes when people become old, they generally forget about or their memory become very weak, dementia type of problem comes. So we can put a GPS tracker in their shoes. So this GPS tracker will keep on sending information to the data server. From data server, we can get information where the person is, and we can track that person very easily. Okay. But all these things are not easily achievable. There are other issues also. So like power efficient, we need longer, better life, smaller footprint, unobtrusive. So it should not affect my day-to-day life. Like old age people are not ready to wear even a smartwatch also. It becomes very difficult for a person which is older one, or which is from old system. They don't use these type of things. Then everywhere connected. So it is to be connected all times, 24/7. Then your data should be secure. It should be cost effective. So all these challenges are there. So I will end here. So even though we might currently have the sophisticated gadgets like Stark at home, but still we are not enjoying fully wearable devices. Future promising all these things at the same time, and we may come across a time where I think we are controlled wirelessly with devices wearing us, being worn by us, and doctors prescribing our medicine without our visit to a hospital or a doctor. So that I think I see in future. So that's and so intelligence is the ability to adapt to change. That's Stephen Hawking. Thank you. If you have any question, you can ask me. Otherwise, from my side, so.
Thank you, sir. It's an honor to hear from you, sir. On the behalf of my college and whole team, I want to thank you for sharing your great insights on the future of wearable technologies. Thank you, sir, to enhance our knowledge base with these frontier technologies like 3D printing, nanotechnology, artificial intelligence, machine learning, deep learning. And sir, you have talked about healthcare innovation in this innovation framework. And I think in this pandemic time with which we are dealing since 2020, it's a need of our like to innovate in the healthcare field. Fine. So I think
Yes,
these
yes.
kind of devices can revolutionize the healthcare system. Thank you, sir, for being with us. Thank you so much.
Thank you, Manu.
Okay, sir.
I am putting, Manu, I am putting, if it is possible, if you people can see this.
Okay, sir.
I have put one link here. This is by NXP. If you people can go and click this link, I don't know whether it's visible or not. There are two links being copied here. Only for last wala jo hai variable wala. So you can see now how they have put some demos, which is totally, I will say, touch type of demos are possible. So this type of technology is also coming these days. I will stop here. Thank you, Manu. Thank you,
Thank
Aarti,
you.
and thank
Thank you,
you,
sir.
SD College.
So much, sir,
inviting
for
me.
joining with us. Thank you so
Thank
much,
you.
sir.
I want to inform all the participants that we are reaching for the time for lunch break up to 1:30. I think all the participants should join at 1:30 so that we can continue with the session at 1:40. Okay, thank you so much. I once again welcome you all on the behalf of Sanatan Dharma College in this one-day national seminar on emerging trends and technologies in current era. So we have reached a valedictory session, and proceeding further in this session, I would like to invite Dr. Gidhar Gopal, Head of Computer Science Department, Sanatan Dharma College, and also the convener of today's webinar. I invite you, sir, to formally introduce the resource person. Over to you, sir.
Thank you, ma'am. So, very good afternoon after the lunch break, and welcome to the technical session come valedictory of this national level seminar. From early morning, we heard about how the technology had advanced the daily lives of each and everyone at every place, and what are the technological advancements in computer science and IT fields, whether it belongs to the wearable networks or in the technologies, as well as in the network models like OSI model, which has been explained in the second technical session also. Now we have Dr. Rajendra Nath with us. He will be delivering a talk on a very renowned topic called Internet of Things, which is partly relevant with the theme of the seminar in an aspect which you can say that technology driven things in different decades have different progresses. Whatever technology advancements are there from 1990s to 2000, from 2000 to 2010, from 2010 to 2020, and now. So it is having an exponential growth in the advancements also. So I once again welcome you, sir. Dr. Rajendranath sir is currently working as professor and chairman in the Department of Computer Science and Applications, Kurukshetra University, Kurukshetra. With more than 33 years of experience, he is actively engaged in his research work. Famously, he's done his PhD in the field of software reusability and presented more than 100 papers in various international journals and conferences. Also, he has presented his research at Queensland University of Technology, Brisbane, Australia, and 15 students have completed their PhD under his supervision, along with more than 250 MTech and MPhil dissertations, and various MCL and MSc level projects also. He has chaired a lot of technical sessions, a lot of in seminars and workshops. He is also keynote speaker in various seminars, workshops, delivered more than 200 to 50 talks in various level at international and international level seminars, conferences at various parts of the country, and as well at the All India Radio and EduSet programs of MHRD India also. His main research interests are Internet of Things, cloud computing, computer architecture and parallel processing, and other advancements in computer and electronics field. He received a certificate of excellence also from IIT Bombay for organizing a 2-week workshop on DBMS, database management system, under MHRD, the Government of India. He has also participated before organizing that workshop in 1-week management capability enhancement program organized by IIM Indore. He is also the central coordinator of spoken tutorial project of MHRD, Government of India. He has very vast administrative experience as the chairman of the department. This is his second tenure as a chairman of the Department Computer Science and Applications, and the deputy proctor of the university, approximately 4.5 years. He is also the coordinator of Entrepreneurship Development Club, Center for Entrepreneurship under RUSA 2.0, as well as the president of IIC, that is Institutions Innovation Council, MHRD, Government of India, in the Kurukshetra University, Kurukshetra right now. Along with this, various universities have sir as UG and PGBOS member on their board, and he's also been the editor-in-chief in various journals like International Journal of Computer Science and Communications, etc. The list is long, but to cut short, because sorry. So let us have our speaker to speak, because we all are here to listen to the speaker, not the introducer. So I welcome you, sir.
Thank you, Dr. Girdhar, and thanks for a nice introduction. Dr. Rajendra Singh, Principal of SD College, Ambala, Kent. Dr. Girdhar Gopal, Convener of the workshop and Head of Department of Computer Science in the college. Dr. Aarti, who is Head of Department of Electronics and IT in the college. And all the participants, it's my great pleasure to be as a resource person in the validity session of one-day webinar, which is national level. So I thought to share my views on interdependence among disruptive and futuristic computing technologies. So all these technologies, names you might have heard: big data, cloud computing, edge computing, Internet of Things, artificial intelligence, machine learning, human augmentation, cyber attacks and their solutions. And many more technologies are also there which have come up. These technologies were developed independently, but now these are not used secluded manner. These technologies have converged together and have transformed the business and brands and have created the myriad of opportunities for innovations and other kind of things which are happening in day-to-day life. So data has become big in terms of volume, in terms of speed. Speed means the rate at which data is generated, and variety of data. That is what we call big data. When data became big, our traditional techniques to process the data failed to process big data. Like Oracle, RDBMS, we were used to process the data. When data size increased, its volume increased, its speed increased, its variety increased, then we are not able to handle these kind of data by using the traditional tools like RDBMS. So to process big data, we were to develop a new technology, that is what we call Hadoop. Hadoop is distributed and parallel processing technology to process big data. What's the size of big data today? This is 44 zettabyte in 2020. 44 zettabyte. 1 zettabyte is approximately 10 raised to power 21 bytes. When I say 10 raised to power 21, then this number may not sound it is very huge number, but actually it is very huge number. If you translate it into how many number of books will be this, then you will find that even one country may be smaller to keep that large size number of books. And it has been estimated that by 2025, our digital universe will be of size 175 zettabyte. So big data refers to the science of storing and analyzing exponentially growing digital data for providing useful insights. So what are the main sources of big data? I mention you some of the sources which are generating the big data. One source is media. Like you see the Facebook, you see the WhatsApp, Twitter, daily how many videos are uploaded, how many messages are passed on, how many images are uploaded. So this is generating huge amount of digital data on daily basis. Second is cloud. In the cloud, companies have developed public cloud, private cloud, third-party cloud, hybrid cloud, so on and so forth. In the cloud, huge amount of data is residing. Third is web. In the web, you see there are websites. Your college has website. Our university has website. All government organizations have website. Rather, every person is trying to have the website. So in the websites, lot of data is stored there. And next technology which has come up is IoT. In IoT, lot of sensors are there. Sensors are churning out the trillions and trillions of data on hourly basis. And databases like India has the unique identification UID database, and which is largest in the world. So this kind of databases, every company is having their own databases. So these are few of sources. I have mentioned that lot of data is generated on daily basis. So to process this large amount of data and to produce insight from this size of data, newer technology we needed to process, and that is what I mentioned is Hadoop. Next is, if this huge amount of data is there, so without cloud, we are not able to store this huge amount of data. So what is cloud? Cloud means computing at your doorstep. Like your water utility is there, you are not aware of from which river, from which well water in your tap comes. In electricity utility, you are not aware of where this electricity is generated. In the similar sense, computing resources are bundled up in the form of data centers, and that forms the cloud computing. And these cloud computing resources are available through your mobile phone, laptop, and desktop, pay-per-use basis. So cloud computing technology is helping us to process big data. So there is interrelationship. If big data is there, without cloud computing, we cannot store huge amount of data. So data storage as a service are available. So there we store huge amount of data in clouds. And when we have the huge amount of data in the cloud, we have to analyze this data, and cloud is providing you data analytics services. So analytics as a service on cloud computing. Analytics as a service on cloud computing. Microsoft, Google, Amazon, etc., many big giant cloud computing companies are providing you software as a service in terms of analytics as a service. So you can utilize these services to analyze your data. So in analytics, 4 kinds of analysis generally we carry out. One is descriptive analytics. It gives you insight about what happened. Like say, huge amount of medical data you created and something wrong has gone, so you can find out what wrong has happened. Diagnostic analytics, why did it happen? Like say, some operation has failed, so diagnostic can tell you that what error has been committed so that this wrong has happened or this result has appeared. In predictive analytics, what will happen? So future we can predict. Like today in medical, predictive analytics are there, whether you are going to have some ailment in near future, are we going to have the heart attack, etc. So predictive analytics are there. And fourth one is prescriptive analytics. How can we make it happen? That means not only one course of thing that can occur, we can make that change and we can choose the another option to happen. So that is the prescriptive analytics. Like doctors are giving the prescription, one doctor is giving say X prescription, Y doctor is giving another prescription. So that is the prescriptive analytics. So these analytics are used in all business today. All businesses are based upon cloud computing. So all these companies like Netflix is very known to you these days, Spotify, Shopify, and many other software as a service companies have built their entire business models on the concept of cloud computing. So you are having the TV on your demand, whatever the movie you want to see, that movie will become available to you. Different members of the family want to see different movies. So that is TV on demand. That was the concept a decade of years back. Now it has become the reality today. What are the limitations of cloud computing? Cloud computing very fast has grown. The volume of data which is there in cloud has become very huge. Processing capabilities are required. Data are stored in data centers. If the processing of data is time critical, like say operations are being performed, so results should be time critical. A missile is launched, it has to hit the target, so this is time critical. Some health hazards operations are going on where the result of processing should come very fast, so that is the time critical. So time critical processings are required in our all spheres of computing. In the cloud computing, latency, that means whatever the command for processing the data you have given and you receive the result of processing, so latency between these two round trip has increased. And then cloud computing cannot be used for time critical operations. Second, according to Gartner, 75% of enterprise generated data will be created outside of centralized data centers by 2025. So in that case, cloud computing, the data outside the cloud computing which will be generated will increase to the tune of 75%. This amount of data puts an incredible strain on the internet, which in turn causes congestion and disruption. These limitations, to overcome these limitations, a new technology was developed, and that is what we call edge computing. So what is edge computing? In edge computing, we process the data near to the source of data. If we process the data near to the source of the data, then that latency that you have to give the processing command, or you have to give the huge amount of data to the cloud for processing, the data will go to the cloud data center, there it will be processed, and then result will be given back to you. So there is a lot of latency, there is a lot of delay. If we perform the computing near to the source of generation of data, then this latency is eliminated. The workload or strain on the internet and communication networks is reduced. That's the concept of edge computing. So in edge computing, at the edges of cloud network, processing is carried out at that place. What could be the edge? Edge could be the router in the internet, it could be ISP, it could be routing switch, it could be integrated access device like your mobile phone, your laptop, your desktop, etc., etc. So in edge computing, the limitations of the cloud computing that I mentioned are eliminated, and without edge computing, IoT of today is not possible. So the technology that I am mentioning, that big data is there, that cannot be processed without the help of cloud computing. In cloud computing, lot of limitations are there which are eliminated by edge computing. If edge computing is not there, then time critical IoT operations cannot be performed. So edge computing is must for the Internet of Things. So here you see cloud computing came, then edge computing came. Computing is performed at the edge of network, and when edge computing is there, then IoT dream can be realized. So now in combination of edge computing and IoT, I mentioned some of the examples. There are a lot of examples. One is automobile industry. We are going to develop autonomous vehicles, autonomous car, driverless car. You see this concept for the last couple of decades we are talking of, that one day car will be driverless. Now this is going to be realized. If you want to develop the autonomous car and you want to use it with the cloud computing, then there will be delays and the autonomous car cannot perform well. For its efficiency and accuracy, edge computing is must. And without 5G network has come up. India is also going to launch 5G network. So without 5G network, without edge computing, without cloud computing, without big data technology, autonomous vehicles cannot be developed. These are interrelated. That is the what kind of interdependence of today's technologies, which are disruptive in nature and futuristic. They have the convergence. Only then these kind of things in the world can happen. Another example of healthcare, like a Fitbit watch is there. Only one example I am quoting. Fitbit watch is there. Everyone is wearing. How many steps, how many heartbeats, how many calories, etc., etc. So many things. Smart watches are there, which are capturing the data about your health, which is stored in clouds. If your data is critical, like say about the chronic diseases like heart attack, your pacemaker, your stunt, etc. So then these data will become critical. If you process that data in cloud, then delays could create the disaster to happen. So edge computing is required. And communication channels are to be very fast. So in that way, 5G technology is also required. Like say operation is being performed from remote and operation is critical and communication network is not 5G. So what I quote you the vision, that vision cannot happen without 5G, without edge computing, without cloud computing, and without big data technology. In agriculture sector, in manufacturing sector, in retail industry, everywhere edge computing are required. In banking, the behavior of your credit card, how long, how often, how is it used. There's huge amount of data is accumulated and predictive analysis can be carried out that some kind of fraud is going to happen and alerts could be generated. So these are some of the applications of edge computing. I tried to mention you just to have the scenario of what I mean edge computing. Then Internet of Things. These applications that I mentioned are of Internet of Things. What is IoT? Name is very familiar to all of you. And as the name suggests, Internet is already there. Earlier, Internet was connecting the people. Now, we are making the Internet to connect the things. So we are connecting the things with the Internet, and that becomes the Internet of Things. If thing is to be connected with the Internet, then thing has to be smart. And what smart I mean, anything that has the processing capability, decision-making capability, then that thing is smart. Like a smartphone is smart because it has the decision capability. What are your interests? It will start ticking on your mobile phone. It fetches those messages in that you are interested. So mobile phone is smart. So anything that we have to connect with the Internet has to be smart. And that thing must have these four things. One is uniquely identifiable. Everything that you want to connect with the internet has to be uniquely identifiable. That is IP address. Computer people will know. Everything has to have the IP address. That is the unique address. Able to communicate. Everything that you connect with the internet should be able to communicate. Like a mouse is smart. So this mouse is able to communicate. It can perform basic computations, decisions, sensing, actuators, all these kind of capabilities must be there in Internet of Things. All the things of your home can be made smart and can be connected with the internet, and that becomes the part of Internet of Things. In 2006, one paradigm shift took place. That paradigm shift was number of devices connected with the internet became more than number of people connected with the internet. And in 2008, number of devices connected with the internet became more than the people on the earth. And now the number of devices connected with the internet has grown to very large, that is around 23 billion. 23 billion. So what's the population of globe today? 7.6 billion. And how many things have been connected already with the internet? That is 23 billion. And by 2025, 75 billion things would be connected with the internet. To connect the devices with the internet, one bottleneck was that of Internet Protocol version 4. As I said that anything that you want to connect with the internet has to have the unique address, unique IP address. And with this protocol, you could generate only 4.3 billion IP addresses, 4.3. As I said, number of people on the globe are 7.6 billion, but with this protocol, we could generate 3.4 billion addresses, and hence the dream of Internet of Things cannot be seen. So to overcome this, IPv6 protocol was developed, and with this 3.4 into 10 to the power 38 IP addresses. That means all the people on earth, all the things on earth can be connected with the internet. This is very, very futuristic. IPv6 protocol has come up already in use today. It has been estimated that the objects that we want to connect with the internet are somewhere in the range of 50 to 100 trillion. 50 to 100 trillion. So after billion, billion is 10 to the power 9, trillion is 10 to the power 12, but unique address is 10 to the power 38. No problem at all. Each person has 1,000 to 5,000 trackable objects which could be connected with the internet. Like at your home, fridge is there, fans are there, bulbs are there, switches are there, room is there, door is there, lock is there, so on and so forth. All these can be made smart. Smart home word you might have heard, smart city. All these are examples of Internet of Things. So when Internet of Things would happen, when I was I joined the teaching profession. I used to attend the conferences like this. Today I am as a resource person interacting with you people. At that time, the people were used to say in their talk, Vasudev Kutumkum, Sari Dharti Mera Ghar Hai. Now, with the incumbent of these technologies that I mentioned, Vasudev Kutumkum dream has been realized. Anyone, anything, anytime, any place, any service, any network. So IT provides you all these things. What are different variants of IoT which are very, very much futuristic in nature? Internet of bodies. Internet of bodies. In our body, we implants out external things like pacemaker, we implant. We send the camera inside to take the photographs. We take the digital pills to release the chemicals in a sustained manner. We have the limbs, we have the cochlear implant, we have the artificial nose. These becomes the part of our body. These are things, but they have become the part of our body. And all these examples that I gave you are connected with the internet. These may be monitored by doctors at all time. They are collecting the data with the help of sensors put into the cloud, processed there, data analytics are carried out, and then doctors make the best decision. That is what we call Internet of Bodies. Internet of Behavior. What is Internet of Behavior? What is the behavior of customers for a company? This is must to be realized. And we form the Internet of Behavior. Patterns. So out of Internet of Behavior, particular pattern of behavior will form the Internet of Things. That is what I am saying, Internet of Behavior. Internet of Brains. One talk generally I deliver is on brain-computer interface. In that, technology has advanced to the level that the brain of two human beings can be connected. Experiment has already been done on 2 human beings, on 4 monkeys, on mice, etc., etc. So that will become the Internet of Brains. Internet of battlefield things. Ukraine war is going on. So many missiles, artillery, other objects which are connected with the internet and controlled. Internet of ground things. So many vehicles are moving on the ground which are connected with the internet. That becomes the Internet of ground things. This is one example only. Your street lights, your all parking places, all are connected, all are smart and are connected with the internet. That becomes the Internet of ground things. Internet of underwater things. Animals are there. These can be tagged and tracked. Internet of underwater things. Internet of space things. In space, so many satellites have been lost. All satellites are smart. Internet can be developed to work in the space. So that would become the Internet of space things. So these are some of the variants I mentioned. In future, these will be myriad of variants of Internet of Things, like what has happened in cloud computing. To start with, you perhaps might have studied, there were 3 services only. Software as a service, platform as a service, infrastructure as a service. Now everything as a service, database as a service, your compute as a service, your network as a service, your machine as a service, so on and so forth. So everything has become in the form of as a service in cloud computing. That kind of thing you will find in Internet of Things. So now you see artificial intelligence. It's not the new concept, but it is very active, hot, and very much required topic. That is AI and ML, artificial intelligence and machine learning. Application of these two you find in your day-to-day life. Whether it is your washing machine, your car, your IoT. So your IoT cannot work without AI. Because in IoT, one machine has to talk with another machine. There is a machine-to-machine conversation. So unless they are artificially intelligent, unless they learn like human being, that is machine learning. So your whole network or all these technologies that I have discussed cannot work in proper way. So AI allows machines to behave and interact like human beings by copying the behavior and capability of reasoning into the machines. That is what we say AI. If you might have heard that the Facebook incorporation, now we say Meta incorporation, that is going to develop artificial intelligence powered universal language translation. So this is under development now. Once this translator will be developed, how many spoken languages are there in the world? You talk in your language, another person will listen in his or her language. So that kind of thing would happen. So this is very ambitious project of Metaverse, and they are developing their own supercomputer also, which will be artificially intelligent to carry out these kind of projects. So couple of years back, they started this project, and after a couple of years, they may succeed. So there is a race, whether human being is intelligent or the thing which has been made artificially intelligent is intelligent. I am not clinging. I am not stopping the debate. Who is more intelligent? I am just quoting a few examples that machines have been made intelligent. In 1997, one computer, Deep Blue, was made artificially intelligent to play the game of chess. And at that time, Garry Kasparov was world champion. World champion was defeated first time by the Deep Blue. This was the first defeat of human being by the artificially intelligent thing. Second defeat recently has happened In reading test, Microsoft artificially intelligent score was 82.65. Chinese score was 82.44 and human being score was 82.3 only. This was the second defeat by the computer of human being. So far, in my opinion, 2 times human beings have been defeated by the things which have been made artificially intelligent. What would happen if things become more intelligent than the human being? So this is the topic. I leave for all of you to think upon it. Robot will translate animal voice into English. We are not able to understand the animal voice, but we are developing the robots. They will understand the voice of voice of animals, and they can translate it in English. If it is in English, then I said that universal language translator is there. So that means any language of the world, you can listen the voice of animals. Sophia robot sings with Jimmy. So this is the humanoid robot, look like human being. Sophia robot talking with the humans. Many people have interviewed Sophia. So one human interview another human. So in that similar way, Sophia was interviewed and Sophia gave the intelligent answers. Robot makes robot. You have to see this thing. Robot makes robot. If robot, like robot movie was there, robot is destroyed and it is regaining itself. So war is going on, robots are destroyed in war, robots are making the robots and then they are going in the war to kill the enemy. So robot makes robot. Teaching profession has also been invaded by robots. Robot professor. Veena 48 gave lecture on philosophy. Veena 48 is name of robot. Robot made painting which was sold worth rupees 10 lakh. Robots are biased also like human being. They recognize the race. Many experiments were conducted. They recognize the sex, whether the man is talking to or woman is talking to, whether black is talking to or white is talking to. So this is some of the glimpse of robotic technology I mentioned. These days, lot of cyber crimes are taking place. Lot of frauds are going on. So what is cyber? Any computing source related with your digital data forms your cyber. Your entire IT is cyber. And cyber crimes daily taking place. Bank frauds, your ATM card frauds, your website hacking, your account hacking, lot of attacks, phishing attacks, denial of service attack, distributed denial of service attack. In Ukraine, Russia has done on Ukraine, DDoS, many websites and working of many plants stopped. So when these kinds of attacks happen, then we find the solution for these attacks. And we have to make use of artificial intelligence. we have to carry out the predictive analytics that there some kind of attack is going to be there. We have to carry out the prescriptive kind of analytics that we can adopt the another course of action if this thing happens, or if we adopt this course of action, that this thing is not going to happen. So all these things will require all the technologies that I mentioned. So the criminals which are attacking the cyber are also using the same technology to improve their attacks. So crime and solution, crime and technology will go hand in hand. So now X wins, then Y wins, then X wins, then Y wins. They will keep on going, things will keep on happening, and we will keep on finding the solution of the cyber crime attacks. So underlying the processing of big data, cloud computing, edge computing, very fast computers are required. That is what you say, supercomputer. So only I wanted to quote you the example of supercomputer. The as of date, Fugaku from Japan is the fastest computer in the world to make its speed fast. 76 lakhs 30,848 CPUs have been bundled up in one computer. In one CPU, if one process is going on, then 76 lakhs processings are done in parallel. But technology has further advanced. On one core, there can be multiple threads, 4 to 16. So you can further multiply it by 16. And its speed is in terms of zettaflop, 0.442 zettaflop. Our one zettaflop is 10 raised to power 21. According to one estimate, brain has 10 raised to power 18 neurons. If all neurons are working in parallel, then 10 raised to power 18 calculations are being done in parallel in the brain. Now its speed has gone to 10 raised to power 21, surpassed the limit of processing of brain. And one supercomputer may consume the power of 29 megawatt, approximately 30 megawatt. That is the power consumption of a small town or city. So this is the supercomputer. This is the speed required. All these technologies are going hand to hand. If this speed is not there, then what I have told you could not have happened. India is also doing well in the supercomputing. The latest supercomputer from India is Csma Cd AI. It is globally at the rank of 62, 62nd fastest computer in the world. So this is the technology that I wanted to describe. And everyone is possessing the smartphone. As I mentioned that the technologies that I mentioned came up independently, but now they are not in use secluded. They are intertwined they are intermingled. So many technologies into your one device, and smartphone is the most important device today. In that, all these technologies are there. If your home is smart, you need to develop the mobile app. Through that, you control your smart home. If your home security is smart, app is there. From anywhere in the globe, you can see or check or monitor the security of your home. So mobile app development companies have the bundles of opportunities to develop and to find newer innovations in this area. So this is the convergence of technologies. So with these, I would like to conclude my discussion. The future trends in technology are very diverse, very intertwined, and very promising, as I tried to tell you in my discussion. These technologies will open a new chapter in the history of IT and make the dreams of today a reality of tomorrow. So with these words, I conclude. If any query, any participants has, most welcome. Thank you.
Thank you, sir. On the behalf of Sanatan Dharma College and the entire fraternity of the Institute, my sincere thanks to you, sir. Sir, for sparing some time from your valuable time to enlighten our minds on such contemporary topics like big data, Internet of Things, edge computing, cloud computing, robotics, and interrelation between them. Sir, you have told us about how these technologies are disruptive and futuristic in nature as well. You have rightly said, sir, that earlier people are connecting through internet, but now we are connecting things through internet, and how we are becoming smart in every aspect, be it smart home, smart things, etc. So these technologies definitely will go one step further to change the way of life and the way of work as well. I sincerely thank you, sir. Thank you so much, sir, for sharing your insights with us. We are very much grateful to you. Thank you so much, sir.
Thank you, Dr. Manu Gupta. Thank you,
Thank you,
Dr.
sir.
Girdhar. I thank principal and entire organizing committee giving me this opportunity. And I also thank participants for listening me carefully. Thank you.
Thank you so much, sir. So, as we are moving further in our valedictory session, now we have presentations from the participants. So I would like to call the first participant. I hope you are ready with your presentation, ma'am. Dr. Chetna Vaidya from Shrimati AAA PG Government College, Kalka, Panchkula.
Yes, ma'am. I'm ready. Thank you.
Okay, ma'am. Over to you.
Good afternoon to all. I am Chetna Vaidya from GC Government College, Kalka. Firstly, I thanks to SD College team to give me opportunity in national seminar Emerging Trends of Technology in Current Era. To present
Excuse me,
my
ma'am.
topic on
Sorry to
mobile ad
disturb
hoc
you.
network.
Ma'am, have you shared your screen of presentation?
I will, ma'am. Please allow me to share.
Okay.
8 minutes. Now you can do.
Just okay, sir. Okay.
Ma'am, can you see my screen?
Not yet, ma'am.
Ma'am, can you
Yes,
see my
ma'am.
screen?
Yes, ma'am. Yes,
Yeah.
ma'am. Your screen is visible.
Thank you, ma'am.
Okay.
Can I proceed now?
Yes, sure, ma'am.
My topic is mobile ad hoc networks. The term, this is my outline of presentation, which we are going to discuss. First is the term ad hoc. Ad hoc means when needed. It means a network that is set up immediately when needed for random temporary access. This network breaks when the connected device go out of that network. Mobile ad hoc network. MANET can be explained as transportable network that can be created and implemented as and when required based on the requirement. MANETs are multi-bonds in nature, coordinated and flexible. The main objective is to provide security given to source, course and goal with the feature self-repairing and auto-configured. It is also known as wireless ad hoc network. Working of MANET. MANET works as an individual exclusively or in a group as a part of huge network. There is no access point or hardware. Device, devices search each other themselves and start communicating. If a node is far away, then the nodes between the source and destination nodes act as routers, so transfer data one by one to make it reach the destination node. The devices can join and leave the network anytime. That is, dynamic node addition and removal happens. The devices have their own backups of energy, like they have batteries for powers. There are some applications of MANET. For military services, it is used for immediately sending information to all remote troops or battalions for meeting. In commercial use, for local conferences, events, and seminars. In emergency services like earthquake, disaster, firefighting, natural disasters, which need services without any infrastructure, immediately service where we want. In education and gaming services, used in classrooms, labs of schools, colleges for sharing lectures, in gaming, in local area network for competitions. Characteristics of MANETs. No centralized control. The working is completely depend on the behavior and support of the participating devices. Random change of devices. Devices keep on coming and leaving the network at the huge pace and voluntarily. Frequent changes in network topology. That is the arrangement of devices in the network. Use limited battery power and human interference. Each device acts as router as well as a head of the network. Just like in traditional networking, there is the need of router. In MANET, there is no need of any router. The nodes act itself the router. These networks have limited little capacity and range of data transmission, that is limited bandwidth. Low resources such as memory power, battery power, backups, etc. Performance is high with low expenses. There are types of MANET. First is daisy chain network, and the second is deep neural network, also called known as feed forwarded neural networks. This is the diagram of daisy chain network. It is a typical type of network topology. A daisy chain is used to direct the connection of network nodes. It is also simple to implement. One node of the network is connected to the next in the line or chain. It can be linear, where the initial and last node are not linked. These are not linked. So this is a linear chain. It can be formed as a ring by connecting the initial and last node. When we connect this initial and last node, then it will become the ring topology, where we can send the data in both directions. So it is called bidirectional passing. In linear, the message must be flow from one system to another in single direction. The daisy chain network is well known for its simplicity and scalability. The user can add extra nodes along the chain up to the maximum extent. Next is deep neural network. Artificial neural network can either be shallow or deep. When artificial neural network has more than one hidden layer, these are the hidden layers, one hidden layer in its architecture, then it is called deep neural network. These networks process complex data with the help of mathematical modeling, which yet we are not going to discuss. In this network, data will be flowing in forward direction only, not in backward direction. Backward direction में data transfer नहीं होता, and hence the node can never be accessed again. These networks need a huge amount of data to train, and they have the ability to classify millions of data. Deep neural networks have an input layer, an output layer, and few hidden layers between them. These networks have the ability to handle unstructured data, unlabeled data. In deep neural network, the signal from one neuron is transferred to the another neuron. DNN is also called feed-forwarded neural network when the input is passed on the output layer by weights and neurons within the output layer to figure the output signals. With so many advantages and strength, there are some weaknesses in MANETs. First is the non-secure boundaries. As a result of no secure boundaries, MANET is more affected by attacks. When security compromises, attacks can result to spoofing of nodes' identity, data tampering, confidential information leakage. Compromised node. Some of the attacks are to get access inside the network in order to get control over the nodes in the network to exploiting them. It means to accomplish their malicious activities. It is very difficult for the network to prevent malicious behavior of nodes. It is very easy for a compromised node to change its position because of ad hoc mobility, because often making it more hard and troublesome to trace the malicious activities. No central management. It is a strong feature as well as drawback of MANET. MANET is self-arranged network. Each of these nodes act as a router, thus can forward and receive packets. MANET works without any pre-existing foundation. This absence of centralized management causes MANET to more insecure to attack. Last is problem of scalability. It is so hard to know and foretell the number of nodes in the MANETs in future. The nodes are free to move inside and outside the MANET, which make it very scalable and shrinkable. Last, the conclusion. Minutes have so much dynamism, which make it necessary technology for the rapid changes happening in the world of communication. With the increase of mobile devices such as laptops, cell phones, iPads, etc., such networks like MANETs are of huge significance and cannot be avoided completely. Thank you, ma'am. Thank you, the whole team.
Thank you so much, Chetna ma'am. We are delighted to have your views on Manet. So our next participant will be Miss Suman, Assistant Professor from Computer Science Department, Government College, Jean. But I would like to request you all that please keep your presentations brief, up to like 4 to 5 minutes. We are really thankful to you that you are giving presentation, but we have also some time constraints. So please keep the time limits in consideration. Suman ma'am, over to you. Suman ma'am, your slides are visible to us, but we are not able to hearing you. Are you there?
Kindly unmute, ma'am. Your screen was visible, but now your voice is not there.
Let me share my screen again.
Sure, ma'am.
Am I audible now?
Yes, ma'am. You are audible.
Okay, let's start.
Okay.
Good afternoon, everybody. I'm Mrs. Suman, Assistant Professor of Computer Science from Government College, Jean. Today, I will present my views on empirical study of role of MIS in education. First of all, let's talk about what is MIS in education, or we can say that EMIS. What is EMIS? It is nothing but it is a flexible information system that collects, store, analyze, and process educational institutional information and student related data in an organized way. This readily accessible platform helps the educators as well as the students also. Now, how EMIS work? There are 5 basic steps through which EMIS work. It first of all, in this we collect and store the entire institutional data, then identify and analyze the queries. The queries may be from the student side, from the parent side, or anybody else. Extract the required institutional data from database. Allow the student administrator as well as the college administrator also to monitor the required data, provide accurate work-related statistics, and generate customized report in multiple formats to foster the decision making. Now, through MIS, different type of reports can be generated. We can create the summary reports, trend reports, exceptional report, and on-demand reports can also be created with the help of MIS. There are 5 key elements of MIS: accuracy, timeliness, completeness, relevance, and consistency. But there are some problems, hurdles in the ways of MIS. Hacking is the main problem. Some student or some unauthorized access also can be a main problem of in EMIS. Data manipulation, sometime wrongly intention the data can be deleted or edited. There are some different problems in MIS, but the advantages of MIS are reliable information. We got the reliable information, timely data we can found, easily readable reports can be generated. Through MIS, teacher and students' performance can be monitored. Teacher can monitor the students' report, and student can find out their attendance or their marks and all, which we'll discuss in the next step. Smart decision making is also the key advantage of MIS, and through which educational delivery can be more better with the help of ICT tools and better utilization of ICT tools. Education delivery can be more efficient way. Now, the benefits of MIS for the students are through which assessment results can they easily find out. If some student is absent, he does not have his idea about his assessment marks, then through MIS he can easily get his assessment marks. He can track his attendance, and he can track the performance also, exams marks and all. And the teacher can real time inside the student's behavior, and through MIS the student's personal data, educational or exam, or if he using the library books and all, this can also be this all information can also be stored with the help of MIS. Now, the benefits for the teacher: no work duplication. The teacher have fully idea about which part of syllabus has been covered and which are the units which he has to be covered also. Attendance and progress of students can easily monitor. He can give the depth knowledge to the students and timetable, and through, because it is with the help of ICT tools, so time and efforts are also minimized. Easily students can get the knowledge from the teacher side. And the conclusion part is that the importance of MIS in education is not only considered the most suitable as putting in the place the appropriate information and communication technology, but also all the problems associated with the information flow will be resolved. However, IT and MIS is more than just the installation of computer systems. The relevant computer software and accessories, it also the willingness of management to purchase the appropriate system software, the acceptance of administrator to use the system, and availability to qualify the ICT personnel to provide the support system. Thank you. I hope you understand.
Thank you so much, ma'am, for
Thank you
sharing
so
your
much.
views. Thank you, ma'am. Now, next participant in the row, I would like to call Dr. Poonam, Assistant Professor, Arya PG College, Panipat. No, ma'am, you are not audible. We are not getting your voice.
Now I'm audible?
Yes, ma'am, you are audible now.
Okay, ma'am.
You can share your screen, ma'am, if you
Okay,
have
ma'am.
prepared a presentation.
Yes, my screen is visible?
Yes, ma'am, it's yes, ma'am, it's visible.
Very good afternoon to all of you. Firstly, I want to thank the organizations to give me an opportunity to present my research paper here. I, Dr. Poonam, with my co-author, Mrs. Aditi Vittal ma'am, are going to present our paper titled as Analysis of Classification Algorithm on Big Data. As we all know, in this era, big data is now not a new word. We all have known by the term big data, and big data are the data which cannot be handled by our traditional RDBMS tools. The reason is that RDBMS can handle only structured data or data in a tabular form. It cannot handle unstructured or semi-structured data. But big data is a heterogeneous mixture of data. It can be text, audio, video, GIF, image, or animated graphics. And this kind of data cannot be stored, handled, and analyzed by our traditional techniques. That's why big data faces three major challenges, three major problems. First, data assessing and computing. Second, data privacy and domain knowledge. And third, data mining algorithm. And the big data mining algorithm are designed to address the challenge posed by our large amount of data, scattered data distribution, and complex and dynamic properties. And the classification is a technique that can be used to find valuable information from the big data. And classification techniques are used to solve the challenges which classify the big data according to our format, and that can be processed and analyzed for further. These are the three major steps, stages for the big data mining algorithm. That is, first is data is processed by data fusion techniques. Second, data mining, and third, local learning model fusion and feedback. As we all know, we have three types of machine learning algorithms: supervised learning, unsupervised, and reinforcement learning. In our paper, we are using supervised learning. And supervised learning is an approach where a computer algorithm is trained on input data and that has been labeled for a particular output. And it is based on a function that map input into an output function. And classification is a technique that comes under the supervised learning that is used to identify the category of new observation on the basis of the trained data. And we have two types of classification algorithm, linear and non-linear. In our research, we take two linear classification algorithm and the two non-linear classification algorithm. And linear classifications support vector machine SVM and the logistic regression. And non-linear random forest and decision tree classifier we are used in our research paper. I briefly discussed about the SVM, and SVM is used to create a baseline and the decision boundary that can segregate n-dimensional space into classes. And logistic regression is to identify the best fit between a dependent variable and a set of independent variables. And random forest and a decision tree classifier both are the non-linear classification algorithm for supervised learning. A random forest classifier algorithm is an algorithm that uses a number of data sets according to the various data set feature, and it is used for average for the final classification. And decision tree classifier, we classify all in separate classes by classifying them according to the data feature. We apply these four classification algorithms on our data set credit card for data set that we taken from the Kaggle. And that data set have 31 columns and 284,807 rows. It is a very huge amount of data. That's why we can say that it is a big data. Here 30 columns are independent feature and one column is dependent. That name is class. Class represent two value, either 0 or 1. 0 represent fraud and 0 represent non-fraud and 1 represent fraud. So it is a classification. 0 number of rows are 284,315 and whose class is 1, that is 492. We apply this 4 algorithm on this credit fraud data and we take the two test size, that is 0.3 and one we take 0.5, and we measure testing accuracy, training accuracy, as well as the execution times in second. And we found non-linear classification algorithms are the best among the random forest and the decision tree. Both have the best testing accuracy and the training accuracy, but execution time is very large in random forest and very low in the logistic regression, that is linear classification algorithm we found in our research. And when we take the test size is 0.5, we found the same result. Random forest is execution time is high and testing accuracy is best in the random forest, and after that decision tree classifier. These are the some output results that we take on random forest with other features, and this is the decision tree output result. Conclusion is that we take two linear and two non-linear classification algorithm, and we found the non-linear classification algorithm provide the best result, but it takes the execution time is large, but logistic regression time is less, but testing accuracy and the training accuracy is less as comparison to the SVM and decision tree and random forest. That's over. Thank you.
Thank you, Dr. Poonam, for sharing your views. Next presentation will be by Miss Ranjana Singh from RKDP University, Ranchi, Jharkhand.
Yes, ma'am. Good afternoon to everyone.
Good afternoon, ma'am.
I'm
You
Ranjana
are
Singh from Department of Education, RKDF University, Ranchi. I'm going to present my paper, and the topic is Role of Technology in Education. I'm very thankful to SD College Ambala Kent for giving me this opportunity. Ma'am, can I share my PPT?
yes, ma'am. Your PPT is visible.
Okay, please allow me. Thank you, ma'am.
Ma'am, if you want to switch off your video, you can.
Yes, ma'am.
If you want. Okay.
Yes, ma'am. Thank you. Okay. Yes, ma'am. I'm starting. Today,
Sure, ma'am.
more than ever, the role of educational technology in teaching is of great importance because of the use of information and communication technologies. With the help of various applications for distance education, the internet, teachers and students themselves, they see the advantage of educational technology. The question is whether schools and teachers themselves are ready for the use of technology in education and whether they are aware of its benefits. The era of 21st century is often regarded as an era of technology. Technology today plays a very important role in our life. It is seen as a basis of growth of an economy. An economy which is poor in technology can never grow in today's scenario. This is because technology make our work much easier and less time consuming. The impact of technology can be felt in every possible field. One such field is education. It was revealed that the use of modern equipment, technology, and tools, the learning and interactivity of students increases. They also find it much more interactive, as well as full of interesting areas. When aided by technology, the transfer of knowledge becomes very easy and convenient, as well as effective. What this means is that our minds now tend to work faster when assisted with the use of modern technology, be it any part of life. Here we talk about education, the reliance and dependence of such an innovation that simply makes life an easy, smooth journey is completely unavoidable these days, even in schools, universities, and colleges also. The role of technology in the field of education is fourfold. It is included as a part of the curriculum, as an instructional delivery system, as a means of aiding instructions, and also a tool to enhance the entire learning processes. Thanks to technology, education has gone from passive and reactive to interactive and aggressive. Education is essential in corporate and academic settings. Jen talks about the enormous challenges teachers are facing in our society due to the rapid expansion of knowledge. The modern technologies are demanding that teachers learn how to use these technologies in their teaching. Hence, these new technologies increase the teachers' training needs. Some teachers do not always have positive attitudes towards computers, and their poor attitudes may lead to a failure of the computer based projects. Also, the most commonly cited barriers are lack of time, lack of access, lack of resources, lack of expertise, and lack of support. Another barrier given by Butler and Selbron 2002 and Csma Williams 2001 is reliability. Reliability included hardware failures, incompatible software between home and school, poor or slow internet connectivity, and out of date software, which are available mostly at school. While the students, educators are having more up to date software at home. And what is the advantages of the role of technology in education? Are it makes students more excited to learn, helps students with busy schedules, freedom to work at home on their own time, trains students to learn new technology skills they can use later in the workplace, decreases paper and photocopying costs, promoting concept of green revolution. And what are the disadvantages of technology? Many experts and experienced people say that due to such technology in education, a student's imagination is affected, their thinking ability is reduced. Sometimes it's also time consuming from teachers' a point of view. It is costly to install such technology. There can be health issues too when used over limit. Some students cannot afford modern computer technologies. And now, conclusion. Technology has a positive impact on education, at the same time may also pose negative effects. Teachers and students should take advantage of this in the good light and eliminate the drawbacks which are pulling back many of students as well as schools from achieving excellence. It is thus time for every country to introduce a more technologically equipped education sector in the future. Thank you.
Thank you so much, Ranjana ma'am.
Thank you, ma'am.
Thank you so much, ma'am. So now I would like to call Miss Monica Singla, Assistant Professor, Department of Computer Science, Government College, Jind. Miss Monica Singla.
Good afternoon, everyone. Am I audible, ma'am?
Yes, ma'am.
And my screen is visible?
Yes, ma'am. Your screen is visible.
Good afternoon, everyone. Again, I'm Monica Singla, Assistant Professor, Department of Computer Science, Government College, Jind. I thank Sanatan Dharm College, Ambala again for organizing this national seminar. Today, my topic is Internet of Behaviors. So the heading of my paper is the Future of Digital World, IoT with Internet of Behavior extension. Let's discuss a brief introduction about Internet of Things and Internet of Behavior. Internet of Behavior is a concept depicting a connecting set of anyone, anything, anytime, any place, any services, and any network, as already discussed by Dr. Rajendra Nath sir during this seminar. The IoT is a big trend in new generation technology that can be thought of as the interconnection of uniquely identified smart objects, devices within today's internet infrastructure with extended benefits. Internet of Behavior can be called as extension of Internet of Things. It is an area of research and development that seek to understand how, when, and why humans use technology to make purchasing decisions. These type of research areas are considered to be the mashup of three disciplines, that is technology, analytical data, and human psychology. So my paper examines the trend of Internet of Behavior, its extensive survey on IoT-based services and applications, and the combined impact of Internet of Things and Internet of Behaviors, various security and privacy concerns, and various data security concerns that can be addressed. So to make our services Internet of Behavior based innovations quite trending. So Internet of Things are the emergence of these Internet of Things in which the devices connect directly with data, the data gathered from different sensors and devices to each other. There are two reasons why this Internet of Things collect data, that is advances in sensors and connectivity technology. These are allowing devices to collect, record, and analyze data that was not accessible before. Then second, the ability of devices to gather data on their own, that removes the human entered data, automatically obtaining the data that is required, that is automated data. Next page shows the applications of IoTs. As you already know, a few of them. First, IoTs are used and very well seen in fitness equipments, fitness related machines, for the well-being of humans, family related instruments, smartwatches, and biomonitored drugs, clinical supports, also in home monitoring. So Internet of Behavior is a platform that is designed to gather, aggregate, analyze data gathered from various wide variety of sources, including household devices, wearable computers, and human online activities. In this, the data is analyzed in terms of behavioral psychology to look for patterns that can be used by marketing and sales team to influence future consumer behaviors. From a behavioral point of view, the IOB tries to comprehend the data acquired from users' online activities. The aim of Internet of Behavior is to answer the questions how to interpret data and how to use that knowledge to develop and promote new goods, all from the perspective of human psychology. This diagram shows how Internet of Behavior works. First, the machine or the devices track the user behavior and then collect the behavioral data using the IoT devices. Then data is analyzed using the data analytics methodologies and machine learning capabilities to extract the useful informations out of the data. Then behavioral science come into action and understand the extracted informations from user behaviors using the behavioral sources to gain the knowledge, and then that is used for the business strategy, how to react to the insights based on the business strategies to achieve the certain outcomes. Then how the Internet of Behavior is more beneficial when it is combined with Internet of Things. Emotions, choices, augmentations, and companionships are the 4 areas of behavioral science, as you all know, that we examine when we utilize technology. Companies that knows us through the data provided by Internet of Things can now influence our behavior using the data provided by Internet of Behavior. Consider there is a smartphone health app to check your nutrition, sleep habits, heartbeats, and sugar level. The app can warn you when there is a potential dangerous circumstances are there and propose behavioral changes that would lead to more positive and desirable output. So we acquire some data and information from Internet of Things, and that helps us to change our behavior, to provide us a behavioral change so as to make a positive and desirable outcome. These are the various sectors where Internet of Behavior is trending these days. Internet of Behavior in business, so it is quite well used by Google and Facebook like companies. So they utilize the behavioral data to provide ads to user from their sites. YouTube also uses this behavioral analytics to enhance the user's view or experience by recommending and highlighting the videos that the user is more interested in. IOB is also used during this pandemic time, and the companies like Swiggy and Zomato, they used this IOB concept very well. Like, for example, they broadcast the temperature of the delivery person to assure the customer that they are well safe when they order online. IOB is also used in insurance industries. Then these are the benefits of Internet of Behaviors. First, it analyzes the customer buying habits and through various platforms. Second, it studies the previously unobtainable data that I already discussed in YouTube. Data about how customer interact with the devices and products. Gain deeper insights into where a customer is in the buying journey. And these are the other benefits of Internet of Behaviors. If we discuss about the challenges, Internet of Behavior is confronted with the adversity of how data is collected, stored, and used. Its level of access is difficult to control, and therefore all the companies need to be aware of the liability of IOB uses. There is a problem in Facebook that your data is not secure when some of your information is accessed by the officials of Facebook. Second, the behavioral data can allow cybercrime criminals to access sensitive data that reveal customer patterns, collect and sell property access codes, delivery routes. So there are privacy concerns and data security concerns in Internet of Behaviors. As in conclusion, Internet of Behavior is an area of research and development that seeks to understand how, when, and why human uses technology to make purchasing decisions. It is used for promotion and advertising purposes and will help business people to improve their businesses by translating the information into knowledge. The IOB takes the collection of data. Thank you so much.
Thank you so much, Monica ma'am, for sharing your views. I think Internet of Things, we are very well aware of the term, but we come to know about some new term as an extension of IoT, that is Internet of Behaviors. Thank you, ma'am. Thank you so much. Now, next, I would like to call Miss Anjana Dhawan, Assistant Professor, Department of Computer Science, Government College, Jind. Miss Anjana Dhawan, Assistant Professor, Computer Science Department, Government College, Jind. Ma'am, your voice is not audible.
Hello,
Yes, ma'am.
I am audible?
Yes, ma'am. Now you are audible.
Okay, ma'am. Thank you.
Okay.
Good
Okay.
afternoon to everyone. My name is Anjana Dhawan, Assistant Professor in Computer Science from Government College, Jain. My topic is study on advanced education arrangement of
Excuse me,
e-learning on
ma'am.
MIS.
Anjana, ma'am, sorry to disturb you, but your screen is not visible. If you are sharing any screen, your screen is not visible.
Sorry, ma'am, screen share नहीं हो पा रही मेरी.
Okay. Okay, ma'am.
Oh,
Rights are already given to Anjana ma'am. Manu ma'am.
Okay. Ma'am, rights are given to you. If you want to share your screen, please share your screen, ma'am. Try one.
मैम स्क्रीन शेयर पे तो कर लिया. एक सेकंड मैम,
Oh,
होल्ड करो.
okay. Okay.
हाँ जी मैम, बट स्क्रीन शेयर एक मिनट. हुई मैम.
No, ma'am.
Now,
No, ma'am, not yet.
sorry ma'am.
It's okay, ma'am. You can continue with your presentation. You are audible.
Okay ma'am. Okay.
Just try in between.
What
If
is
okay, ma'am, you can
what
continue.
is MIS? Organization conduct their operation through the use of people, procedure, and information system. How to use the technology to support at the business operations through the using people, process, and the people to use of technology. In the business organization, information and communication technology management is the discipline that is devoted to the administration of the information and communicate technology. As the student study management information system, you may expect get a computer database network and computer security, as well as learn how to assist other in making better use of technology. You are a vital link between the technology and those who do not understand it well as you do. You in which we learn in the many
in which we learn about the career in management information system and degree that combines the business and technology. There are different kinds of internship in MIS. For example, e-learning, learning models, library management, management information system, student information systems, faculty information system. For example, in faculty information system are used to manage and automate administrative process involving instructor, staff, course, and the intersection between these activities. In our typical faculty information system database record, there are 4 types of information: faculty data, IDs, names, department, course, personal data, and password, date of birth, department, and employees data. While the primary purpose of the faculty information system is to coordinate faculty and the university's administrative operations, that learning process is not regarded to be part of the primary goal, and is as a result it is not deemed e-learning on its. There are methods in MIS use, although keeping the overall purpose of the research in mind, even though the researcher intended to cover the entire population, administrative officer, and the entire population. The researcher was only able to obtain completed questionnaires from 49 of them out of total population of 199. As a result, the effective the effective proportion of the overall population who answered to this poll amount of 24.62%. The result in MIS, the finding the clarity indicate that though a majority of the male respondents are not sure whether the database related to the teaching and non-teaching staff, a majority of the female respondents do not think that the database related to the teaching and non-teaching staff. A majority of male respondents, that is 58.82%, were not sure whether the database relating to the teaching and non-teaching staff. A majority of the female respondents, 53.34%, did not think that the database relating to the teaching and non-teaching staff. 33.33% of the female respondents were not sure whether the database relating to the teaching and non-teaching staff. The majority of the respondents of the age group of 30 to 39 and the 40 to 69, that is the 66 to 67% and 58 to 33% respectively, were not sure whether the database relating to the teaching and non-teaching staff. Conclusion: e-learning trends, e-learning trends and the manage the learning process not only to manage universities management information system are not by the itself and e-learning ignoring the learning process while designing and developing e-learning system. Thank you, ma'am. Okay.
Thank you, Anjana ma'am, for your presentation. So this was the last presentation of this session. As we reach the end of this valedictory session of this one-day national seminar on emerging trends and technologies in current era, now may I take this opportunity to invite Dr. Arati from Department of Electronics and IT, Sanatan Dharma College, Ambala Kent, and also the coordinator of this seminar, to kindly propose the formal final vote of thanks to conclude this session. Over to you, Arti ma'am.
Thank you, Manu ma'am. Thank you so much. Good afternoon, one and all present here. As all good things come to the end in the life, so is the today's seminar too. On the behalf of Department of Computers, Department of Electronics and IT, and on the behalf of Sanatan Dharma College, Ambala Kent, I take this opportunity to propose a vote of thanks to those who are directly or indirectly contributed in the seminar titled Emerging Trends of Technology in Current Era, organized by our institute. At the outset, I am thankful to our chief guest, Dr. Anil Vohra, Dean of Colleges, Kurukshetra University, Kurukshetra, our resource persons, Dr. Rajendra Nath, Head Department and Applications, Kurukshetra University, Kurukshetra, Dr. Rajesh Khanna, Professor, Department of Electronics and Communication Engineering, Thapar University, and Dr. Himanshu Monga, Head Department of Electronics and Communication Engineering, Jawaharlal Nehru Government Engineering College, Sundarnagar. We are really enlightened from the words of all these academicians. We are thankful to our honorable principal, Dr. who is the real force behind all the works we do in our institute. A special thanks to Sir. I am also thankful to the organizing committee of this seminar for their unflinching support and coordination in all the work which were required to conduct this seminar. I am also thankful to our lovely participants who are listening to the all resource person since morning. With these warm words and kind messages, we move to the end of the today's seminar. Thank you so much, everyone. Over to you, Manu ma'am. Please share the feedback link. I hope you have already shared.
Yes, ma'am, I have already shared the feedback link. I request all the participants to please fill the feedback form. Please fill your details carefully, as we will be taking your names and all from this feedback form only. So please fill the details carefully. I would like to thank all the dignitaries, convener, coordinator, everybody on the behalf of Sanatana Dharma College and all the fraternity of the institute. Thank you so much. Thank you, everyone.
We will wait for 10 more minutes as you fill the feedback form.